Hello, any query from nodal centers? Yesterday I sent mail to all the local coordinators with evaluation pro forma and receipt format for the honorarium. So you have to get this evaluation pro forma duly filled by all the participants.
Okay, sir.
It is very much required for the certification purpose. Without this evaluation pro forma, certificate will not be issued. So, I hope some nodal centers still they have the problem for connectivity. So, 8 ही चल रहे हैं. So let us continue. So most of the centers have been connected now by this time. So let us start with our subject matters. So I will engage this session. मेरा वो कहाँ से आएगा, इसको क्लोज कर दूं? Okay. क्या खुल रहा है? कुछ और
यही है सर?
नहीं ये
OFC
पीछे ये कैसे क्यों?
सर ये PDF ओपन किए ना? PDF
ओके वो बना के रखी है ना सीडी बनाने के लिए. ओके. So good morning. I'm going to start the session now. So it is on OFC systems, performance evaluation and simulations. So we have discussed now all about optical fiber communication system, starting from the historical developments. Then we discussed about the optical fiber, optical sources, optical detectors, all design considerations. Then from point to point link or single channel, how we can utilize the light as in WDM or DWDM technologies. And we also find that if we go from single channel to multi-channel, it is the mean of using the optical fiber more efficiently, but then different type of non-linear effects also comes into picture. So Dr. Singh, he covered different type of non-linear effects which are there in the optical communication system and how to mitigate these problems. As a result, we have to need lot of maintenance, lot of techniques are required to correct the signal. Then we also discussed about these optical amplifiers, which is a solution or you can say direct amplification of the signal without going to any other, converting the signal from one form to another form. But EDFAs, they introduce a noise. The major noise is the ASC. So ASC noise, we have to filter this noise to run the system efficiently. So at all the stages, we have to check what is the performance of the system. The performance parameter is the bit error rate. So we either measure signal to noise ratio, Q factor, or bit error rate, and all the system they are always specified at particular bit error rate. At what rate the the system is performing. So that performance has to be monitored, has to be checked time to time. And then now, of course, all these systems, it all comprises of hardware. In the telecommunication, all there are the hardware unit, and the field is the systems are in the field. They are laid maybe all over the globe, and as a result, it is very difficult to realize or practice these systems in the laboratories. So just for the educational purpose or for the research and laboratory purpose, we know we have to study these systems now with the help of computer, with the software. These are very, very powerful tools. So now different type of simulation platforms are also there. These are called usually maybe photon design analysis systems or photon transmission systems. So different type of names have been given to these. So basically these are the simulations. So all these hardware systems, they are now designed using the computer simulations or different software. So now through these simulations, I can study the system. One can study the system with the help of simulators. And then, of course, there may be some difference between the simulations and real experimental part. But nowadays, these simulator platforms, they have been so refined, so precise that even more than 90 or 95% accuracy has been achieved with the simulations and experimental part. So I will show you even the comparison of different simulations and experimental part. So whenever you perform the simulation, they have to be validated experimentally. They help us to plan the experiment. They help us to evaluate the experiments also. So I will start with this part. So I already discussed that in order to fulfill the requirement of the society, of the demand of the society or need for the capacity, we have to look for high capacity DW to OFC link. So high capacity DW OFC link, they are fulfilling the requirement of the IT based society or communication based society. And this is the basic block diagram where we have the number of users. They may be operating at different wavelengths, and all these wavelengths now they are multiplex. They are put on a very, you can say, a major backbone optical fiber which is connecting maybe from nation to nation or city to city or from villages to villages depending upon the requirement. So all it is put over the optical fiber. And in optical fiber, there is attenuation, there will be broadening of the pulse. So we have to amplify the signal, we have to regenerate the signal, or we have to compress the signal depending upon the requirement. We have the amplifiers, we have the dispersion compensators, or there is also a requirement of provision for add and drop. So in a system there should be provision. I can add the signal at any place, and I should be able to drop the signal at any place, so that the system should be fully utilized and should be profitable also. And at the end stage, there is a demultiplexing, and then ultimately the optical signal is converted into electrical signal. Now this electrical signal is given to the user, so that his instrument, his telephone, or any electronic device may work on this electronic signal. So this is what system we have in the present day scenario. Again, I mentioned in all these systems, we have at all the stages, all the components, they add different sort of noises. So noise is added to the system at all the places, and even the parameter performance of the system has to be measured at different places. So we have to go for different measurements, different monitoring, where we need different instruments for all these purposes. So I mentioned about these two parameters. These two parameters are major parameters for any communication signal, whether it may be electronic signal or it is a photonic signal. So there is always some sort of attenuation. Attenuation of the signal which is related to power loss. So your power of the signal will be attenuated, it will be lost. So as a result, maybe at the destination, you may not be having sufficient power for the detector to respond. So in that case, we have to amplify the signal. So I need the required level of power or required signal to noise ratio. Similarly, On the other hand, there will be broadening of the pulse. The light signal, specifically in light we call it as a dispersion. So dispersive property that lead to broadening of the pulse. So again, if there is a broadening, there will be a crosstalk. So signals may interfere or overlap. So in that case, our quality of the signal will not be the desirable. So as a result, again we have to find some way or some technique to resolve these pulses. So these pulses should be completely resolvable, distinguishable data has to be there. So in order to check this performance, I mentioned there, we also had a session in the laboratory also, where we demonstrated that mostly we use the bit error rate. Nowadays, mainly we have the digital system, so we measure what is the Q factor or what is the bit error rate, and we draw the eye diagrams or the patterns. So from eye diagram we can check the eye opening. So and how much is the eye opening, opening the eye, closing the eye, or intermediate eye. All they give me the qualitative estimation of the quality of data. Then if you guess from the qualitative that in the eye diagram there may be some problem, then we can go for the Q factor or bit error measurement, and ultimately we find what is the bit error of the system. If this bit error is within your specified limits, specified tolerance, then we can accept the system. Otherwise, we have to go for some sort of maintenance or some modification has to be required in the system to operate at desired data rate or desired tolerance levels. So eye diagram we have already discussed. How to calculate the bit error rate, that we have also covered even in the lab also. So and this in your signals, you have a problem in the bit in the rate in the data will be because of the two factor. One is the noise. So noise is associated with the attenuation mostly. So this may be signal to noise ratio. The noise may be from any of the component. Even our amplifiers, they add different type of noise. We have the ASC noise, we have the short noise, we have the Johnson noise, we have the dark current noise. All different type of noise. They add up, they accumulate, and as a result, our signal to noise ratio falls. So some signal to noise ratio has to be maintained, and other is the distortion. So distortion is basically related to the timing problem. So related to timing, related to broadening, related to dispersion. So if there is a distortion in the system, so there will be a lot of jitter in the signal, and that also affect the bit error rate. So if both these are present, your signal will not be of a right quality. So we have to go for the maintenance, we have to go for the correction of the signal, or what you call the path engineering has to be required. So in brief, if you see, if you have any system, your signal will be affected by many parameters, many mechanism or many phenomena. So generally signal will degrade. So this degradation we have all covered. It may be because of the dispersion in the single mode. It may be material dispersion. It may be waveguide dispersion. Mostly, we will consider here only the single mode propagation, because in telecommunication it is a single mode where the dispersion is minimum, because we want the system to be operate at a high data rate. So dispersion, which we call as the chromatic dispersion or intramodal dispersion, then dispersion because of the non-linear effects. Because when you have a WDM or DW system, or what you call as the multi-channel system, then many non-linear effects comes into picture. So we have to also correct for the non-linear effect. Because of non-linear effects, there will be more fluctuation in the power. The power level may be different, the broadening may be different, there may be transfer of power from one channel to another channel. So all these non-linear effects, they affect the signal. Then we have the loss. Another parameter is the loss. So where the loss is because of the attenuation in the fiber, maybe because of the supplies, because of the connector, and there may be many other parameter or bending of the fiber. All they lead to loss of the system. So there are the inherent losses, there are the extrinsic losses. So all they contribute to the loss. So the total loss be in the signal to noise ratio, we will get what is the total loss. And then all the components they add to the noise. So it may be gain. So in order to overcome this loss, we may go for the amplification of the signal, where the amplification, depending upon how much gain is required, so it will amplify the signal, but on the other hand, it will add noise to the signal. So we may use different type of filters or different type of technique to improve the signal to noise ratio, so that we should get the desired data rate. So these are the major factors which contribute to signal degradation. So signal degradation is there in the system. So we have to correct it. So we have to use some technique. Earlier one method was the repeater. So in a repeater we amplify the signal. So in order to cope up or overcome the attenuation, we have to use repeaters. Repeater is simply your amplifier. So it is earlier one convert the optical signal to electronic signal. Then one use the electronic amplifier. It amplifies the signal to desired level. Then again electrical signal was converted to optical signal, and to achieve the desired signal to noise ratio. In between, we may have to use the noise filters to improve the signal to noise ratio, or to achieve the desired signal to noise ratio. There is always for a particular channel some fixed signal to noise ratio is there, and that has to be achieved. So depending upon the signal health. Again, depending upon the signal health, we may require the regenerator. A regenerator, it has more features. So instead, along with the amplification of the signal will be reshaped or retimed, so that it should reach at the right time. Mostly it is used in the digital systems, or when we have the synchronous type of communication. So in that case, your timing, your shape of the signal is very, very important. So, and another parameter like dispersion is basically pulse broadening, and for that purpose, if there is broadening the pulse, we will not achieve the desired data rate. So in order to achieve that part, we use what we call as we use some dispersion compensator. We know that dispersion is because of different mechanism, but all those are the theoretical features, that those are only to understand what are the mechanisms, what are the phenomena which contribute to the broadening. Then we go for the different type of techniques to overcome those problems, but practically we have to compensate the signal. So whatever is the broadening of the signal, we have to compress it by that means, so that at the device level, at the detector level, I should get right kind of the signal. It should have proper amplitude, it has proper timing or proper width. So mostly that is achieved by dispersion compensating fibers or fiber barrage grating. They are used in both the configuration, either in the pre-compensation or post-compensation. So in pre-compensation scheme, we first at the start we compress the signal by known amount, because you know how much is the length, you know how much will be the broadening in the fiber. So if you have a 50 kilometer length, you know that the dispersion slope of the fiber will be maybe around 10 picosecond per second. So after 50 kilometer, the pulse will be broadened by 500 picosecond. So we have to at the start you compress the pulse by that means. On the other hand, it can be after the fiber. So after the 50 kilometer, you can put a compensator or compression device. So either you compress the signal at the beginning, or you compress the signal at the end of the fiber, so that before it go to the assessing device, it should have right width. So DCF or FBG, they are used for this application. So I will briefly give you some idea about this. So amplifiers, now in order to maintain the system, amplifier may be required at different places. So I already mentioned here we use all optical amplifier. So it may be your semiconductor optical amplifier, or it may be your fiber amplifier. But mostly we prefer the fiber amplifier, but because in this case everything is over the fiber, and it is very, very compatible with the fiber also. Whereas in case of semiconductor optical amplifier, it is just like a laser module. It is a semiconductor laser, which is a block type, and the dimension, there is a mismatch of dimension, and because of the coupling, there may be some more loss at the coupling point. So you have to couple the amplifier at both the stages, at the front end and at the rear end. So during this, so two joints are required for the coupling. So amplifiers may be line amplifier. So when you assess the signal, where the signal to noise ratio falls, we can use a line amplifier. So line amplifier is within the link. So where the signal falls to below certain specified level. There may be pre-amplifiers, so depending upon the requirement. Pre-amplifiers are used before the receiver. So before the receiver, I can have a pre-amplifier so that it should amplify the signal to the desired level, and the level should be above the sensitivity of the detector. So my power at the detector should be more than the minimum power required for the detector to operate. So it may be pre-amplifier, or then it may be booster of transmitted power. Sometimes, in some cases, especially in the local area networking, we need more power because the power has to be distributed among the users. So in those cases, we need the boosters. So boosters are just to boost the power from the source at the beginning, so that when it is distributed among different users, they get right amount of power. Similarly, booster of signal booster at different stages is required, because if you use the boosters, even in case of the general optical fiber, because of the high signal to noise level, there may be more non-linear effects. So this is mostly in case of situations where we have to distribute the signal to different users. In those cases, it is preferred. So amplifiers, they are required at different stages. So I mentioned we mostly use the optical amplifiers. It may be a semiconductor optical amplifier, it may be a Raman amplifier, or other fiber amplifier. So SOAs, they offer a key technology of amplification, switching, wavelength conversion, or regeneration of optical networks. However, the drawback of SOAs include high coupling loss. So the device have to be, this is a block larger in size, so it has to be coupled to optical fiber. So wherever there is a coupling, there is a loss. So high coupling loss and polarization dependence, because here the signal is used in the feedback. Some power is reflected in order to get the laser action. So signal, it becomes polarization dependent. So there may be more polarization, more dispersion in this case, and of course higher noise figure. So noise, they also add the noise. There is more noise in these semiconductor optical amplifier because of the feedback part, because noise will also be amplified during the amplification. So then other type of amplifier are the fiber amplifier. One prefer that let everything will be on the fiber. So here in the fiber amplifier, these are either the Raman amplifier or we have the erbium doped fiber amplifier. So Raman amplifier, in this case, the gain is not so flat, so wide, and it needs very powerful signal. The pump power in case of Raman is very high, and Raman effect is a very big effect. You may get the Raman amplification maybe at long distance. So here, whereas in erbium doped amplifier, you can have a small length, and erbium is doped over the fiber itself. Both have different mechanism. One is based on the Raman scattering, other is based on the stimulated emission or laser action. But EDFA, they are more promising, but they work only in the 1550 nanometer range. So this is how the optical amplification, we have the input signal, the signal passes through the amplifying medium, maybe erbium doped fiber medium, which is already in the populated inversion state with the pump source. So when the signal passes through this medium, it is amplified. So we get the amplified signal at the output. This is just the schematic diagram where we have the signal from the laser. There is a pump. We have the either 980 pump or 1480 pump, depending upon the requirement. So now both these signals, they are coupled by WDM, because these two wavelengths, they are different. So when the signal pass through this erbium doped fiber, the fiber is the material, the 980 pump, it will help the medium to be in the populated inversion state, and this 1550 signal, it will help as a trigger, so it will lead to the stimulated emission. Ultimately, we get the high output. It is the carrier which has to be amplified. Signal will automatically be amplified by the amplification curve. So at the output, we get the amplified signal. So we will get the amplified signal. We will also get how much is the pumped signal. So we can estimate how much power can be consumed, or this power can also be further utilized even in a feedback loop. So this is the schematical. If you look at this, is a block component where we have the all different parts, and we have a fiber where you have the input signal. There is a pump laser on this part, and we have the input signal from one of the fiber pigtail, and we will get the output signal at other. So it is a lump type of amplifier which is between the fiber, but it is of the dimension similar to the fiber. So with these amplifiers, the major problem is if you look at this, the output characteristics of this EDFA, this is the pump input signal, and your output signal will be with lot of ASC noise. If you have this is your signal, of course signal will be amplified, but a lot of noise will be added. And this is a spontaneous emission. It is an incoherent emission. It is a random emission. The light will go in all the directions. So it will not be a coherent. So it will be incoherent. A lot of ASC noise is there. So we have to filter this noise. Otherwise, all this noise will interfere with our channels. In single channel, there will be more noise. But when if you have a multi-channel, so this noise will interfere with the maybe adjacent channel. So it will create the problems. So we have to use ASC filter for these applications. Another part is what is mentioned is the gain flattening. The gain in EDFA is not uniform. So if you look at the signal, if you have an input signal with all the same power levels, when it is passed through the from the amplification, from the output of the optical amplifier, your signal will not be, all the levels will not, power level will not be same. So there is a power differences, and because of this power difference, if such type of signal fall on the tractor, it may lead to the different undesirable behavior, or what you call at certain level the signal may go to the the tractor may go to the saturation state, and because the power in some cases the power is mu. So in that case we have to go for the gain flattening. So gain flattening is very important requirement in case of the optical amplifiers. So this is what we have to, the gain flattening. If you look at this curve, the gain of EDFA, it depends upon the operating window. At different operating window, the amplification will be different, because you may see very flat curve, but practically actually it is not a flat curve. It is some sort of curvature curve, where at some places, depending upon the wavelength, here the wavelength, the amplification may be different, here the amplification may be different. So different level of amplifications will be there. So you can see the gain is not, it is not totally flat, there are the variations. And on the other hand, one have to use some sort of technique. There are techniques which be say gain compensating fiber gratings or Raman amplifiers may be used to lift the particular level. So maybe hybrid amplifier or other amplifier. Dr. Tiwari, he discussed about all these techniques or about these all mechanism. We use different amplifier in combination so that we should get the right kind of signal with minimum noise and minimum gain variation. So we may use some techniques for gain flattening. So this is how we can get all these hybrid integration platform or hybrid integrated platform facility for photonic circuits, where many components are required to get the right kind of signal. Now they are also made using all these semiconductor waveguide or silicon photonic technology. Another point I mentioned that each amplifier will add the noise. So for long link, we use number of amplifier, and if you look at this noise level, each amplifier it will add noise. So this noise level will go on adding. So maybe at some stages the noise this is your signal, this is the ASC noise. It will go on increasing with the each amplifier, because we are not able to totally filter out this ASC noise. Some noise it will be added by all the amplifier, and maybe after a certain number of amplifier we have to use the regenerator. So we have to regenerate the signal at those stages. So in that case, the signal may be separated out from the carrier, then signal is refreshed, reshaped, then again it is the modulator. So your regenerator is basically a total what you call as the source and detector back to back. We have the detector, we refresh the signal, then it is put over the source. So that's why we need the regenerator after few number of amplifiers. Otherwise, it is difficult to get the signal to noise ratio. So each amplifier adds some amount of noise. So that noise accumulate, and at the end stage, it is very difficult to cope up with the signal. So we go for the regeneration of the signal or refreshing of the signal. So again, depending upon the health. So depending upon the noise level of the amplifier, one can decide where to put the repeater and after how many number of amplifier a repeater is required. Yesterday we talked about discussed in the EDFA that if EDF, we can study the characteristics of EDFA as a function of input power. So depending in amplifier, the gain of your EDFA again will depend. It is a input power dependent. So if your input power is very high, you may not get the right amplification. So there is a amplification curve for EDFA. After a certain level, it will fall. So one have to decide how much where to place the amplifier. So that's why we need the optimization. So for all these parts, we have to check all these effects. So amplifiers, of course, they are the solution for the attenuation, but they need many other techniques or many other components to get the right health of the signal. So this was how to maintain the power. The second part is broadening of the pulse, how to manage the dispersion. So dispersion management is another requirement. So in that case, theoretically we study different type of dispersion, different mechanisms are there. They may be taken care during the design of the fibers. Just a minute. Hello, Anji Doctor Sahab. Thank you for coming. Okay. Bilkul, definitely. Okay, thank you. Wish you best of journey. So we have to manage the dispersion. So in that case, I told you practically we have to restore the signal. Like in our amplifier, we have to restore the signal. Similarly, we have to restore the signal in terms of the bits of the signal has to be maintained. So in that case, the practical solution is the compensator. So whatever is the broadening of the pulse, you compress it by some means so that I should get the right kind of pulse. We know that when the signal travel in the conventional single mode optical fiber, it get broadened. So if your signal get highly broadened because of the spectral line bits of the source, so this signal then pass through this type of fiber we call is a dispersion compensating fiber. These type of fibers are also available, has also been designed by different companies like Corning. This is the DCF38 is specifically designed to compensate Corning SMF28E plus fiber. So these type of fiber, they have the negative dispersion slope. They have the different design. Like if you look at the dispersion curve for the fiber, we have the material dispersion, we have the waveguide dispersion. Waveguide dispersion is negative. So by design of the fiber, we can increase this waveguide dispersion to large level so that it should be negative dispersion. So negative dispersion means compression. So these are the fiber with large negative dispersion or negative mostly waveguide dispersion. So when the signal travel through this fiber, so depending on the dispersion coefficient, depending on the dispersion slope of the fiber, one can choose the total dispersion in a particular span of fiber should be 0. So I will show in the next slide. So these dispersion fiber, they were designed for specific purpose. But now they are used in a high data network link. The purpose, when I mentioned about the specific purpose, you see initially when the system was developed, what was the optical window? 850 nanometer. Then one shifted to 1310 nanometer. These development may took some time, maybe 5 or 10 years. So during this period, long length of fiber they were laid for the networking. The advanced country, they opted that technology and they laid the long length of the fiber over the countries. So as a result, when comes the 1550 nanometer window, or when comes the EDFA. So there was now the means, we know the 1550 window has lot many advantages. It has higher bandwidth, or the optical amplification EDFA is available only in the 1550 nanometer window. So everybody want to shift from 1310 to 1550 nanometer window. And we also know the fiber is optimized. When you have to use the fiber maybe for 1310 or 1550. If you go to 1310, we know at 1310 the attenuation is more. So you can use the optical amplifier. The amplifier will attenuate. It will amplify the signal. But if you go from 1310 to 1550, dispersion increases. It means you cannot operate at high data rate. You know the curve for dispersion curve for the conventional fiber. Minima is at 1310. That's why we go to the dispersion shifted fiber. So if you want to use the same fiber for 1550 nanometer window, it will not be optimized for 1550 nanometer. So as a result, one have to use some technique. So as a solution to this problem, now there are two options. Either you replace whole fiber with 1550 nanometer optimized fiber, or you compensate the dispersion. So whatever is the broadening because of shifting from 1310 window to 1550 nanometer window, you compress it by that means. So that is what is how they were developed. So in the dispersion compensating fiber, of course they have the design is different from the conventional configurations. Here the waveguide dispersion is very large. The purpose is to get negative dispersion coefficient, negative dispersion characteristics. So these are the single mode fibers with negative dispersion characteristics. I showed you the design for the dispersion shifted fiber, dispersion flattened fiber. They were totally different designs. Similarly, DCF is also different design. There may be different pore dimension, there may be different cladding dimension, there may be multi-claddings also, it may be multi-core also. So as a result, our aim is that the dispersion should be negative. So this is negative dispersion fiber. So what will happen? In that case, if when the signal travel in the conventional fiber, you see the dispersion increases. From this figure, you can see that dispersion increases with the dispersion slope. There is an increase in the dispersion. Maybe after 100 kilometer, the pulse will be broadened, maybe by few picosecond. After 100 kilometer, if you look for a normal dispersion silica fiber, the dispersion slope is around 16 picosecond. So after 100 kilometer, it means it will be broadened by 1600 picosecond, or by order of 1.6 nanometer. So pulse is broadened by a large amount. So as a result, now I can have a dispersion compensating fiber. So depending on the DCF, dispersion slope of the fiber, when this signal enter the dispersion compensating fiber, it will compress. Again, this compression, the length of this will depend upon the compression factor. What is the attenuation coefficient or waveguide dispersion coefficient, DW? So in that case, the length will depend upon this slope. The total, here the calculation is the total dispersion of the link has to be 0. So D1 L1 plus D2 L2 equal to 0. You know, in the conventional fiber, D1 is 16 picosecond and L is your link length, L1 is your link length. So after few kilometer, now what is the value of D2? D2 is negative. So if you have to compensate for 100 kilometer, the broadening will be 1600 picosecond. So I need, let us say D2 is minus 100. So in that case, 16 kilometer of DCF is required. then the total sum will be 0. Nowadays we show total dispersion in this case will be 0. So this is what is the technique, or what is the in our Punjabi language we call it the jugaad. So jugaad is also come here in order to sort out the problem. So again now the DCF fiber, lot of work is going has been performed, research is performed in this. Nowadays even DCF fiber, they are available with more than minus 300 picosecond per kilometer slope. So if even more than that, in the literature I find that the dispersion fiber with even minus 380 picosecond per kilometer is also available. So in that case, commercially, if you have a 100 kilometer link, means with a standard conventional fiber, how much length is required? 4 kilometer. So after 100 kilometer, you have to put only 4 kilometer. So instead of replacing whole of the fiber, if this is a more beneficial solution. So after 100 kilometer, just replace the 4 kilometer. That will save lot of time and lot of budgets also. So this is what is there in the what is the dispersion compensating part. So very small. So again, it depends on the dispersion coefficient. So larger the dispersion coefficient, lesser is the length of DCF required. So this is. So the design of DCF, you will see now. I already mentioned in the dispersion modified fiber, you have to there are different fiber parameter. The dimension may be different. The decreasing the core radius. By decreasing the core radius, we can shift the dispersion slope by changing the relative refractive index, by playing with the refractive index profile. So with all these variations, one can get a dispersion compensating fiber with large dispersion negative dispersion slope. You see here, number of design has been proposed. In normal conventional fiber, the dotted line it shows we have the core and cladding. But in this case, the core may be of different size. It may be double cladding, it may be triple cladding, or even more cladding layer may be there. Or your core may be segmented core. So in this case, you see the delta is large delta. But generally in the conventional single mode fiber, we keep delta small, less than 1%. In this case, the refractive index of core and cladding is very small. But in this case, you see there is large difference in delta from here to here. This is the one difference. Then from here, so different value of delta are there to get the desired value. So this is the one case where the dispersion slope is minus 98. Here the delta is 2.5%. Here the dispersion slope in this design, the dispersion slope is minus 34. Here delta is also 2.5, but double cladding. So nowadays, even the commercial fiber, they are available with very high value, maybe of the order of minus. So in this case, if you use this fiber, say in earlier case in a 100 kilometer, so after 100 kilometer, you may have to put maybe around 14 or 50 kilometer of the fiber. Whereas if you use the latest fiber with minus 400, so 4 kilometer or 5 kilometer of DCF is required. So we can use the dispersion compensating fiber for this application. What is the drawback of DCF? The DCF, there is a mismatch of size. Because the diameter has to be reduced. The geometry is different. Now it is not a core and cladding. Conventional fiber, it has only core and cladding. DCF fiber, the cladding is different, refractive index is different, and even the cladding layers are maybe more than one. So as a result, there may be lot of Fresnel reflection. So losses are generally more in the DCF. So it means you need more amplifier at shorter distance. So or you need more amplifiers also. So DCF, there is a problem with the DCF of high loss. So generally they have the more loss, so one have to look for this problem also, because and on the other hand, when you make the supplies, in the splicing, if you are splicing the two fiber of similar dimensions, so losses are less. But if you are splicing the fiber of different dimensions, the loss will be more. So again, it is a splicing issue also. So in order to again overcome this requirement like our amplifier. We go from normal semiconductor optic amplifier SOAs to fiber amplifier. Similarly, here we want that there may be some device, some compensator which is itself on the fiber. So that approach we already have discussed, that is the fiber brag grating. So fiber brag grating can be designed or can be manufactured over the fiber itself. So I showed you yesterday how to make a fiber brag grating. So a fiber brag grating is a grating over the fiber. So now you can have multiple fiber grating at certain distance, or you can have a grating which we call as the chipped grating. So in the chipped grating, the distance between the line is not same. It is variable. If you go from left to right, you see the difference grating, what we call the grating index, or D, 2D sin theta equal to, so we call it as the grating period. So grating period is different. So it means at this point different wavelength will be reflected, at this point different wavelength will be reflected, at this point different wavelength will be reflected. So we use normally chipped fiber brag grating. Now if your input pulse, when it comes in the conventional fiber, say after 100 km, it will be broadened. You get, there will be what we call as the blue shift or the red shift. Now when this pulse, it will go to the circulator, or in this device, the pulse will go to this side and it will go to the fiber brag grating, then it will come back. So when it enters the fiber brag grating, now the start portion of FBG, it will reflect the lower wavelength, say lambda r. This portion of the FBG, it is designed in such a way, or grating period is chosen in such a way so that it reflects the blue part. So your pulse broaden. So you cut the red part, you cut the blue part. So ultimately you will get a chopped pulse. This is just similar to chopping. So you have chopped the two ends, and you get the narrow pulse. So this is the one approach. Now in this case, FBG is fabricated over the fiber itself. So there is not a coupling problem. So they are of same dimensions. So this is of course maybe the better than the using of DCF. But here, what is the limitation? You can guess. You are cutting this portion. So during whatever is the information in this region, that will be lost, because our information is over the full mode. So that information will be lost. So there may be loss of data, or you may need you have to add more what we call the redundancy. You have to again attain the data. So in that case, there is one limitation of this part. Another way how we can use the FBGs, that is in terms of the delayed signal. So this is it is the same FBG, but it can be used in different manners. So FBG this is another principle. So when you have an input pulse, so the pulse is broadened. Now it will go to this part. Now FBG is designed in such a way that now this is the faster region. This is the blue pulse. It is moving with very, very fast speed. Now let this pulse, you allow this pulse to go up to this region. So it will cover long distance, then it will come back. So it will take long time to come back. Then the central pulse, the FBG, we have this part here, the reflected part. Now this region of the pulse, it will move up to this point, then it will come back. So it will cover shorter distance. Then the red portion, which will be coming at the late. So it will come. So this portion, it will come at this portion, and it will be reflected back from here only. You see, what in cricket you call the short run. So it is short run. It will cover in shorter time. So as a result, all they are the FBGs, they are placed in such a manner so that after covering this distance, they all reach at the same time. So this is called the delayed technique, delaying the pulses. So that now in this case, your pulse will be at this pulse, you will get the narrow pulse, because your pulse is nothing but it is the timings at which all the components come. So in this case, there will be no loss of the signal. there will be no loss of the signal. So this is more preferable, you can say, use of the FBG in this manner, but we call it the delaying the signal, delays. These are called the getting introduced wavelength specific delays. So accordingly, the placement of FBG one can choose on the fiber in this manner. So this is how we can compensate the dispersion without losing any information. So design compensation part is there. So I already mentioned we have to, in any OFC link, we have to go for the dispersion monitoring, we have to go for the power monitoring, what we call as the dispersion power maps. So I already mentioned the approach in both the cases is to reduce the effect of dispersion and the attenuation. So using the dispersion, we negate the accumulator, and using the amplifier, we amplify the signal. So I already mentioned that DCF can be used in the pre-compensation technique or in the post-compensation. Now it has become standard with the amplifier to use the DCF because it is required. So now we may have the combined module amplifier and DCF. So they are both, we already know this part. Then when the signal pass in this DCF, this is the amplitude power map. In the when the from amplifier it goes to the DCF, and we know that in the DCF the loss will be more. We have now more loss, so we keep the power level somewhat higher, so that I should again compensate for the loss in the DCF. So when it enter to the fiber, now this is the optimum level of the fiber. This is the optimal level of power. You know, because I know in fiber how much is the optimum power. So amplify the signal by somewhat more amount, so that whatever is the loss in the conventional dispersion compensating fiber, that may be compensated. So then it will go here again at this stage. The amplifier, it will amplify the DCF. When it goes to there is a large more loss, so then it will attain this level. If you keep the level certain higher, so again it will travel. Similarly, in the dispersion, you see when there is a dispersion standard value of optimum pulse, when it enter the DCF, now it is compressed. So this is compressed in such a manner so that the total slope when it travel in the fiber, it should be 0. So in this case, it is D2L1 plus D1L1, D2L2 plus D1L1. Whereas in this case, it will be D1L1 plus D2L2. So compression is after you allow the pulse to broaden, then you compress it. Here, you first compress it, then allow it to broaden to the standard value. So this is how they have to be maintained in order to run the system at efficiently or at the optimum level. So this is how we maintain the system, and I already showed you this diagram or schematic in earlier part also. So we need number of components in between. Now you have the different wavelength. We have to check all these the signal health at even the output of the transmitter. We use the optical spectrum analyzers or other device to check the even the state of polarization. One may use the polarization controller so that there should not be mismatch in the polarization. Then mostly at the high data rate, we use the external modulation. These are the different modulation schemes. One may use a post amplifier after at the modulation. Then the signal travel in the optical fiber. Then we have the DCF and amplifier combination. Now the line we call now your repeater is not only the amplifier, it is a DCF plus amplifier. So both the components are there in the repeater or regenerator. Then again, so different spans can be there. So we have to use the inline amplifier after certain defined span. So once it reaches at the near the receiver, we may also amplify. You may have the pre-amplifier there, and then at the health, we may need some band pass filters so that the signal should be of right quality or noise to be removed, and at the detector I should get the right kind of the signal and right kind of the clock also. So mostly, so at the receiver we get the required signal by managing the dispersion and attenuation at different levels. So this is here, this is an example of 55 wavelength WDM link where a transmission data rate of 1.1 terabits per second has been achieved. The data runs at 10 Gbps, and we have the number of lasers to get the desired data rate. So this is how we practically we manage the system, or we maintain the system at specific level. So this is what our hardware part. In case you have any doubt or any query, so we can discuss here. Then I will move to the simulation part. So any doubt or query from class? Our knowledge center, if you have any doubt or any query related to this portion, we can discuss even at this stage also. Before moving to the simulation part, in case you have any query or any doubt, yeah.
Hello, sir.
Good morning.
Sir, I am
I'm not. You are not audible here. Lot of disturbance in your voice.
Hello.
Hello. Just tune your mic.
Hello, sir.
Hello.
Hello.
बोलिए मैम.
Sir, good morning.
Good morning.
Hello.
Hello.
Yes, ma'am. Question
Hello,
is
sir.
audible है.
You
Hello,
are
sir.
audible. You ask your question.
Sir, what type of device we will use in the booster for application purpose, sir?
In booster, it is the amplifier. In booster, we have to amplify the power.
Then
We have
what is
to,
the difference between the amplifier and the booster, sir?
no, it is an amplifier but used at different places. Booster is a amplifier used at the start of the signal, at the source itself.
So
We
what
have
type of device we will use there? For example,
amplifier, normal amplifier, optical amplifier, because your signal is optical.
okay, sir. So same amplifier we can use in the
Yes, definitely. Its power may be different. Its gain may be different.
Okay, sir.
Because at the inline, it may be inline amplifier, it may be pre-amplifier, it may be booster. The gain may be different.
Oh, in all the cases we will use the same device.
Yeah, it is amplifier.
Okay. Thank you, sir. Thank you.
Yeah. Question from any other center? Hello, Gate Odisha, do you have any query?
Hello, good morning, sir.
Good morning.
Sir, actually, I have the doubts regarding the splitter and sorry, what is that?
Completed at WDM?
No, sir. Splitter is dividing that coupler and splitter.
Okay.
Hello.
No, coupler.
Sir.
You please repeat your question.
Sir, what is the exact difference between coupler and splitter? Coupler is dividing the signals and splitter
No. Coupler is combining the signal.
Coupler is combining the signals.
Yeah, it is combining the signal. Splitter is splitting the signal.
Okay. And what is the difference between a splitter and a flocker?
Splitter and
Fork, F-O-R-K.
F-O-R-Q, fork.
Yes, sir.
That I don't know. Fork I don't know, but it is.
Actually, sir, in optic system there is a simulation. One box is there that is called fork. So I am asking that.
You have to read from the help file of the software. What is the role of fork?
Yes, sir.
Yeah.
The role of fork.
You have to see it from that, because this terminology they have given. I have not come across this term in my
Okay.
study. Or It may be some sort of splitting, but maybe different parameter.
Okay. Okay, thank you, sir.
I will find in future what is this fork is.
Okay, sir.
It is in OPSIM?
Sir,
It is in OPSIM or OPTI system?
in optic system, sir.
Okay, I will find but fork it. For what purpose it is used there.
Okay, sir. Thank you, sir.
Okay. So now let us move to the next part. Now I mentioned that in a hardware level we need number of devices, we need the number of systems, and every part is in the field or in the laboratory. These are very expensive components used for the transport purpose. So sometimes they cannot be disturbed also because communication is going on. Even if your system is off for a few moments, it may lead to so many disturbances, so many loss of information may be there. So as a result, now in order to study the system, in order to evaluate the system, now we have the simulators. The simulator basically is your some platforms, some softwares where all these components they are modeled and they are designed, they are evaluated in such a way so that whatever is the input output in any of your hardware component, I should get similar type of behavior using the computer software. Now many our electronics part, it is all based on our software or our they have the computer interfacing. All those issues are there. So we need the simulations. So in order to undertake research or in order to evaluate the system, now simulations are very important, very beneficial for all these uses. So this is what the statement from you can say pioneer of optical fiber communication system, Dr. G.P. Agarwal, who is professor at Institute of Optics, University of Rochester. As optical systems become more and more complex, scientists and engineers must increasingly adopt advanced software simulation techniques for vital assistance with design issues. PDTS photonic design transmission systems power and flexibility facilitate efficient and effective photonic design and analysis. So all design and analysis can be taken with the simulator software. There are many, these experiments are very expensive. You cannot accept the failure of the system or failure of the experiment. So all these are first simulator. There are many scenarios where simulation is very much required, where the experiment cost is very high, or you cannot accommodate with the failure of the system. Then first test with the software. If your software is giving the positive result, then we can go for the design aspect or hardware aspect. So simulations, they are very important for these applications. So these are not only simulation, but I will call it as a simulation and modeling tools. So they use numerical methods to predict and evaluate behavior of individual fiber component. It may be your data source, it may be your voltage source, it may be your transmitter, fiber, connector. All the components which are there in your fiber optic link, they have to be modeled. They have to be designed in such a manner by using the numerical method so that they should give me the same output but is there in a hardware component. So it is there in the link and networks. So computer-based simulation and modeling tools that integrate component. I should have some model, some software which have design software for the individual component, then for the integration. So when you integrate, but you call it the scheduling. So integration, link and network function, so that it has to be more efficient, cheaper and faster also. So now we know the computers, they are very faster, they can perform at very high data rate. So on the other hand, they are much cheaper also. If you look at the cost of computer, day by day they have come down. You will not find increase in the rate. So as a result, one have to look for that part. So rapid proliferation and increase of the capabilities of the computer. The capability of computer, if you compare the computer of 1940s or computer of 2020s, there is a lot of variation. lot of speed capability, lot of calculation capability. Now they have moved to very sophisticated simulation programs are possible. So because these are the PDAs, photonic design automation tools based on well-established numerical methods. So it is a numerical method which are very useful in this part. Simulate factors such as connector loss due to geometric and position mismatch, efficiency of coupling optical light to source, so coupling loss, signal behavior in passive and active component, and performance of complex optical network. Now it is possible with the numerical methods. Model devices such as waveguides, optical filters, waveguide grating arrays, optical amplifier. So all these components now they can be designed or they can be modeled on the using the computer simulators, and unable to use, visualize and simulate a system quickly with reasonable accuracy. So all these they are on in the visual form like graphical user interface. So you are able to recognize the component, and it should be the software should run with reasonable accuracy and with very high speed. So all these are the features which are there in the simulator. So role of simulator is to enable the study of complex inter and intra-component interactions numerically to correct prediction of the interaction. So all these components they interact, and that interaction the software should be able to predict the interaction mechanism. So what is the output of the interactions? So implementation of the rigid design cycle using latest technologies. So there should be upgradation of the software from time to time. Whatever is coming in the technology that have to be opted, that have to be accommodated or implemented in your software. That's why all these software every year you will find different versions of these software. So nowadays, every year or maybe twice in a year, you will find the new version because the technology is improving. New additions is added in the technology, and same have to be implemented in the software. So simulators and its libraries. It is a library which is very important. So larger the library means you have more and more modules, different components. You have more flexibility for design. So libraries are become standard design platform for individual researchers. So as a result, they should be in the standard format. So complex interaction could involve intermodulation, feedback, reflections, all resonance, all these they have to be incorporated. We should be familiar because with the upgradation of technology, earlier it was only the point-to-point link, then one moved to WDM, DWDM, and now TDM is also integrated on the DWDM. So all the feature had to be added. So I already mentioned the characteristics of a simulation and modeling tool. These are basically the theoretical models which consider the approximation and models. So in the telecom, one have to go for the approximations are reasonably accurate and acceptable in general. They should be in the real system. They should not just be just like the imagination. So they should exist in the reality. Whatever you consider, you assume they should be in reality in existence. So computational efficiency allows a trade-off between accuracy and speed. So I should be able to evaluate the system. Because these are a large numerical picture, they take long simulation time. So I should be able to run these programs within the reasonable time to check my system, looking at the other problem. So allow for quick estimate of the system performance in early stage of the design. I should be able to estimate whether the program is going in right direction or there is some modification is required. It is not that after 1 week of the running the program you find some parameter was wrong. So at the different stages there should be monitoring or checking of the system. So that's why in all these simulations, if those who are working, you will find all type of monitoring devices are there. You can monitor the signal even at the initial stage to at the final stage. So it enables user to visualize and simulate a system quickly, creating user libraries and graphic user interface. So it should be graphical information placed so that it should be easier for the user, and one should be able to add to the library. Whatever, because all users they are using they are designing the component, there should be provision that whatever you design it can be added to the library, so that library become bigger and bigger. So library is always known how many volumes are there. So it is a library which is important for any of the simulators. So generally, if you go for any simulator, you will find the graphic user interface, which allow for the choice of the component. You should be able to identify the component. Like somebody asked about the fork, what is the role of fork? It should be defined. So if you click at the properties of the fork, it will tell you what is the role of the fork. Scheduler, it set the execution order. So in which order the execution to take place. Because all the components, the signal will transfer from user to destination. So from source to destination. So execution has to be in the same manner in which the signal actually perform, actually travel. Then libraries, I already mentioned, one have to library all these models, whatever component is, there may be the variable form of the components are variable, with component with variable properties, because the users, all the users, they may have different requirements. So as a result, we need the library model with variable, with different properties. So I should be able to assign different value to a particular model. So that's why you will find the properties. If you go to the property of any component, there is a provision you can set any value. So, and that should be reliable also. Then of course, core simulation. Nowadays, if you are, so it means there should be, the software should allow interoperability with third-party software. It should not be only restricted to one type of language, because now it is the interaction. If you allow other software, you design some component, it's in MATLAB, in C++, in any other language, in the software there should be provision to utilize that information or that component. What we mean by core simulation. So but you design something in your software, or what you call the open source software. So I should be able to component with to integrate with the open source softwares, because it will otherwise it will add to the cost of the system. And verification. Whatever you perform with the simulation, somebody has to verify. That has to be validated. Because on the computer, you give any value to the computer, you can set any value, it will accept. It will not say no. But in practically, you have to see whether it exists or not. You may set fiber diameter say less than 1 micron, but look practically whether it is possible or not. So it should be a real or acceptable even on the practical aspect. So one have to compare your simulator result with the experimental values. So experiment, that is what you call the validation. So validation or comparison between simulation and the experiment is very much required. So there are different type of these simulation software and modern tools are available. We have some of these software is available in our laboratory also. Commercially, I come across generally the important software. We have the BPI. It is a visual photonic interface. So under this is by the international company. So BPI. So this software, there are number of packages in this. So they laid with different type of environment, but transmission maker is a one package which deal with the communication system. So we can have the transmission maker BPI. If you come across any optical book in the optical fiber communication, maybe by Kizer, maybe by GP Agarwal or other books, you will find they have given some examples using these software. So you can use because they have evaluated this software. So Kizer's book is based on BPI. Then RSoft they have the OptiSim and ModSys. OptiSim again, transmitter maker. OptiSim is a optical platform for single mode fiber. OptiSim. Similarly, we have the ModSys for multi-mode fiber system. In BPI is the transmission maker. You can simulate both single mode and multi-mode. But whereas in RSoft, they have different models for single mode and ModSys. So of course there are many other parts also, band solver, grating for grating, other packages also. But I will consider it only to that for the transmission purpose. Similarly, we have the Opti system. From Opti company, this is the Canada-based company. So they have the Opti system and amplifier design. So in this, even Opti system, it simulates both single mode and multi-mode fiber. Both model can be simulated, and there is another benefit that here we have the amplifier simulation also. In other system, amplifiers are there. They are design amplifiers, but you cannot design their own amplifier. You can use the library with number of features, but you cannot design simulate your own amplifier. Whereas in this, you can design your own amplifier. So all these are very big platforms where you can simulate or model any of the communication system, starting from very basic system to very high, sophisticated high capacity system. So these can be used for designing either of the photonic component or communication system, a complete communication link, or any optical communication network. They have strong libraries, so all these features are there. I will not spend much time on this. So these system design tools enable the user to simulate a wide range of network. In the second session, you will find optical amplifier, optical network. Balinder Kaur, she may show some simulation also. She have worked on all these simulation software for designing all these networks. She may show some examples also. So this is how, if you open any simulation software, all these simulation software, they are the commercial software, they have the license, they are licensed software. They have the single license also, they have the network license also. And we know the benefit of single and network licenses. So if you open any simulation, this is the from OpSim, LinkSim is the earlier one module, LinkSim, now they have changed the name to OFC. So if you open the software, you will find all these components here. Number of components in the library you will see here. So, and in order to design your own project, you have to open the project from the file. So this software, it runs in different modes. One is the simple mode, other is the block mode. So in both the technology, both the strategies, the way of evaluation is different. In one software, it evaluates block by block. In other software, it evaluates in terms of the timings. It sends us a data, evaluate it, so it is working in a loop part. So both options are there. Depending, you can go to their literature. In all these software, you have all these tutorials, all these examples. So one can learn from there how to utilize particular component. Now, whatever system you want to design, you can just click on one component and drag it to the project. You can bring all these units one by one and make your system. You have a design and you put your component according to your requirement. So at here you will see you have a data source. So number of data sources are available. Number of transmitter sources are available. You can have any transmitter source. You have to convert your digital data into electrical pulse. Then multiplexers, or then you can have different type of fibers. So you can have your amplifiers. You can have the DCF and different loops you can create. So different spans, so depending you can have any length. And all these components, if you click the right click on any of these components, you will get the properties. So you can set the properties as per your requirement. You can set the data rate, you can set the type of data, NRZ, RZ, or any other format. You can choose the laser, but the wavelength, power, or line widths, all component can be chosen here. Similarly, the quality of fiber, what is the attenuation, what is the dispersion, what are the nonlinear parameters, all those can be, you can set in the properties, and then accordingly you can have all these parts. So you can set all these parameters and you can assemble the system. Even at the output stage, you can set you have the electrical signal. You can set the electrical devices also, like your BR meter, your power meter, or any other type of measuring instrument. They are also available in the library of these softwares. So you can look at the spectrum. This is the 4-channel wavelength vision multiplex. You can check at the input state and what is the behavior at the output state. You can see lot of noise or lot of sideband have been added to it. It is all because of the non-linear effect. It may be because of the SPM or because of the four-way mixing or because of some sort of Raman scattering or other scattered peaks. So if you have only 4 channels, then it's not a problem. But if you have a more channel, then these peaks may interfere with that channel. That will lead to interference. And from there, these peaks, they will come from the major channels. So power will be reduced because of these peaks. So we have to look for all these factors. So all these type of features instruments are there. You can have check the BER, and then of course you can evaluate. You can have the eye diagram. You can evaluate the BER. So all these features are multi features are available with the software. This is simply other example which I showed you. You have a 4-channel system, one channel, second channel, third channel, fourth channel. So you can evaluate the system. You can check at the type of the spectrum. There may be another topology, another example where you can design according to your requirement, and you can analyze your output in different manners. Your simulated result can be in the different manner depending upon the requirement. So many options are there. You have the eye diagram, you have the contour diagram, you have the BR contour, you have the other frequency chips. So different type of comparison patterns are available. Dispersion compensation is available. If you want go for the dispersion compensation, we know we need the dispersion compensating fiber, so you can use that part, and ultimately you can have the dispersion map. So dispersion map and power maps can also be there, can be arranged in these simulation. Only you have to learn from the example. Everything is inbuilt in the software. Tutorials are available or demos are available on their website. You can use these for different purpose. Demo is available for all the software. Even you can go for the evaluation license. All these companies, they provide evaluation license for one month. So you can write to them. You can fill the form there on their website. Then they will send you the license for 1 month. So after 1 month, license will expire. So you can now send your feedback. You can test whether it is of your use or not. It gives you help in deciding to buy or purchase the software. Similarly, this is the polarization mode simulation. So that can also be simulated with software. You can check what is the behavior of polarization. Now we have the cable TV network, or these are the different networks which can also be designed. Now you see most of the systems, they also run in the network form. So maybe 4-channel transmitter with different type of formatter. So all signal spectrum, signal scattering diagram, number of patterns can be there with these networks. You can add whatever, because all these are the network in different topologies or with different requirement. But the basic component are your fiber component. You have the data, you have the modulator, you need the fiber, you need the demodulator, and some measuring devices. So these are just different configurations which can be put in use. So then another, simply if you go for this opti system software, only the window will be different, but all the model, because ultimately all these software they are designed for a single cause, for your photonic communication system. So the goal is same. So they may be available in different GUI or different symbols. So again same, if you open it, you will get number of components, and then you can design your link. So all these links are possible. Number of features are there in terms of the spectrum. You can look at the different spectrums. You can look at different values also. All these, they are available in the qualitative form, in the values also. You can set how much is the power, all these parameters. You can have set these properties, analyzers, then similarly a visualizers. So qualitative and visual, you can draw any sort of graph in the graphical form. All these users are there. So you can choose any format. Now the performance of the system is also format dependent. You will find in the search, in some system, NRZ data is there. There may be RZ may be better. If you look at this part, in case of NRZ, you are not able, the system is not able to perform at these values. Whereas in RZ, you have the signal at these points also. So similarly, other format, CSRZ, MDRZ, so many type of formats options are available. So you can compare, you can study which is more efficient for particular system design. Different DPSK, all these are digital formats. So DPSK depending upon 30% duty cycle, 50% duty cycle. So all these ratios, they are the parameters for your DPSK type of signal. You can have QPSK type of signal. All these are all your digital format. You have to learn for all these parts. Then you can go for the optical design also. I mentioned in opti system, there is a benefit that you can design your own amplifier. Whereas in other software, this design option is not available, specifically in OFC. So, but here you can have the erbium doped fiber amplifier, you can have the zirconium material, you can have azopium zirconium combination, you can have any other reference material. Any material, rare earth material. Mostly our amplifier, they are the rare earth material. So any rare earth material can be chosen, and you can design. You can select the diameter, length, all these features. They can also be designed with these software. So optimization, like I mentioned, in these optical amplifier, they have the problems of the gain flattening, ASE noise. All these type of features are there. So you can go for the optimization in terms of the gain flattening of the signal. So if you have a different type of gains, this is all your ASE. So by using the ASE filter or gain flattening, I can have the very small noise or the equal gain. So I can improve, look at the signal to noise ratio and all these factors. Then I mentioned all these software, they have the provision that whatever you can design in the standard software, like in optoelectronics, in other areas, MATLAB or Simulink software, they are very useful. So one can design on these softwares, and then you can export the output of these software to your standard platform, or you can export, you can import from both flexibilities are there, and then you can study the system. So you may design any component in the MATLAB or in Simulink, then you can utilize it here. The rest of the component, so there has to be compatibility of the software, and it is there in all these softwares. Similarly, multi-mode link, you can have the single mode link, you can have the multi-mode link. Here, only in place of the single mode fiber, you have the multi-mode fiber, and you have the multi-mode sources also. So these features are also available. Then nowadays, Dr. Singh, he mentioned about the Li-Fi, or it is a free space optics. Now you can have wireless communication also. It is not that it is not possible, but we find there are a lot of disturbances, and now you find Wi-Fi, especially in your microwave communication, your mobile tower, it is usually in the 2 to 3 kilometer range. So as a result, even our lasers, they can be utilized for all these applications, but I mentioned only the laser, they cannot be at the ground level, because they are very dangerous, very harmful. If any laser light fall on the retina, it may cause the permanent blindness or permanent damage to the eye, or even they may affect other body parts. So as a result, they are not allowed just as a wireless. But now free space optics, satellite to satellite communication, now there is a concept of vertical developments. We have tall buildings. So from one building to another building, we can have a free space communication. Then in between, there the wiring is required. Of course, in the house, the wiring is required. It can be Wi-Fi in that case. So Dr. Singh, he mentioned many advancement, many topologies where we are looking for the Li-Fi or Wi-Fi or other options. So same can be designed here. In this software, you can have transmitter, and in between, you can have the different type of channels. So in between, you can add the disturbance. The disruption may be because of the rain, because of the fog, because of the pollution, whatever you want to add, you have to model that. You should know all those parameters. Then you can simulate how the signal attenuate. It is the only case is the attenuation will be more. So you can simulate the system, and you can check how much distance it is possible. So free space optics is another area. Then we have to check for the belly reaching. performance budget. So in this system, now this is a one example where you can have your transmitter configuration, you have your receiver configuration, and you have the total link configuration. You can have a transmitter, receiver, and you can design a link. It is a experimental validation, so you can simulate the same part. Now you can have the transmitter block or different loops, then you can have the output. From the experimental, you have the data. So in this case, in the comparison purpose, you see these blue dots, they are because of the experimental part, and red rectangle, they are because of the simulation part. So you can see here the agreement between the two. So even your simulation result, they may be very, very accurate. So depending upon all these parts, so simulation, whenever you go for simulation, your result will only be reliable, only will be accepted by the scientific society if it matches with the experimental part. Because ultimately the role of simulation is to develop the technology, to provide support, to provide help for development of the technology. So one have to look for all these features. So you can look at the eye diagram also. This is the eye diagram, the experimental eye diagram after at the start or at the 40 kilometers. Similarly, this is the simulated part. And you can check the result. These are the measured value and these are the simulated values. You can see in the simulation, you can go to any value. But in experimental, you need the device, you need the component in order to perform the experiment. So things are may not be available in the experimental part, but those can also be simulated in the simulation platform. So you can predict the behavior of the experiment or you can predict the trend of the function. So again, another simulation part. So you can see this is the measured result, these are the simulated results. So different signals, and you can find they look like same type of signal. So these are the capability which our photonic system should have. I mentioned that one parameter, the usability. It should be a powerful tool and easy to use. Integrated design, simulation and analysis environment should be available in the software so that it should be user friendly. Accuracy. Of course, accuracy is very much required, and user can either enter parameters that can be measured from the real device. So whatever parameters you choose, they should be basically maybe from the real device, or they should be in accordance with the real devices, and then they should be matching with the test and measurement equipment, with the standard equipment. Whatever test and equipment you model in your software, they should be matching with the parameter provided by the different companies, like your DSO, your spectrum analyzer. They should be basically matching with the real instrument. Then expandability, I mentioned your software should accept the models from another software like MATLAB or SPICE or maybe LabVIEW, or all those from these software. You should be able to integrate your program. Your software has to be compatible with these software, and ultimately the flexibility. I mentioned that automation of design and simulation using integrated different languages, different software. It should not be it should be only the language specific. One have to look for all these. So visual feature has to be there. So it should not be difficult to identify the component. So I should visually identify the icons. Icons should be in such a way that one should be easily able to identify all these components. So all these features are of course available in the standard software, but they are available, so they can be utilized for all these applications. So in order to study more efficiently, it is not that we have to develop a lab, because development of lab, it will cost a lot. But for research purpose, for study purpose, we can also have these software, these simulation platform, so that you can add something to the scientific society, or you can generate the useful data for the design purpose, for the other user, for the testing purpose, or for many other applications. So I will stop here. I gave you just the idea about the different type of simulation softwares which are available, which are commercially available, and which can be utilized in order to understand the communication system, in order to evaluate the communication system, and then looking for their compatibility, and that may help in development of the technology, or that may add some boost to the technology in the time to develop. So I will stop here. Thank you very much for your patient listening, and in case you have any query or any question, you are most welcome. Any query from our classroom?
What is the difference between DPKS or QPKS?
So these are the digital format. One is the D stand for double, Q stand for quarter. So any signal, you can divide it into 2 parts, or you can divide it into 4 parts. Then you can evaluate. So these are the digital format, like our amplitude modulation, or we have these frequency modulation. Basically, these are the phase keys, phase shift, PSK, phase shift key. Now, phase can be, you can have the double, you can have the quadrature. So digital format, you can go for this. We have to go in more detail.
So these simulation program is also useful for other scattering, like Raman scattering, Milan scattering.
So then there will be different programs. These programs, they are only for the light communication system. Even this may not be applicable for electronic communication system.
Only for Rayleigh.
Only for?
Rayleigh scattering. These
No.
are only for Rayleigh scattering, sir.
No. Rayleigh scattering, you are talking about only about the fiber. Rayleigh scattering will only be in the fiber. So Rayleigh scattering plus Raman scattering, Boolean scattering, SPM, 4-wave W wave mixing, they are also available with the fiber. You can set these parameters. But if you want only to study the Rayleigh scattering as an individual study, that is not there. There are on and off features. You can put the Rayleigh scattering on, you can put the Raman scattering on, you can put 4-wave mixing on. So then they will be included in your evaluation part. Okay?
Can we see any optical simulator here in the lab?
You can come in the afternoon. We have in the lab, because that is a licensed software and working on a particular IP address. So I cannot bring that IP address here, because that is a machine that is specific. So if anybody interested, you can come to the lab, then you can spend time. OptiSim, both OptiSim and ModSys is available, and OptiSystem is available. Maybe in the coming year, we will have also, we are in the process to procure BPI also. Because BPI is a high cost, it is very more expensive than the other softwares. So any query from nodal centers?
Good morning, sir.
Good morning. Good morning. You may ask your question.
Dispersion is basically bad for optical fibers, and then you have discussed negative dispersion.
Okay.
Is there any drawback of negative dispersion fibers?
You see, when you have an optimum system, when you optimize your system, it means all your optical devices, they will work at specific type of pulse. But if that pulse will deviate from its value, so the performance of system will change. So that's why the DCF or negative dispersion coefficient, they are designed for specific purpose.
Okay.
Yeah, they are benefit only for the compression. If there is a broadening, you can compress it. But if your pulse is already optimized and you compress it, then your behavior of your system will change from the optimum value.
That means they are deployed after performing calculations.
Yeah, they are deployed after performing calculation.
Okay, thank you, sir.
Yeah. Any other query from different nodal center? देखिए फजोदी को है सामने. Any question from your center? So I suppose there is no other question. So we will stop the session here. So then there will be tea break. So after 15 minutes, we will again come to the center for second session, and that session will be on optical networks, and then and other network, OFC network and radio on fiber. Now it is not that fiber can be utilized only for the optical type of data. It should be a universal fiber, or you may call it the hybrid behavior of the system. Or we always now in many areas we go for the hybrid type of system, so that it should be compatible with all type of environment. Similarly, approach is there, and Dr. Baljeet Kaur, she will discuss on this session. So let us have a tea break, and we will come again after 15 minutes. Okay.
मतलब पिलर प्राइस है सेट है
ପୁରା ସେ ଯୋଉ
ବନ୍ଧୁ ସର ଦେଖି ଜାଣିଲା ଭିडिଓ
ଯେ ବେଶୀ ଦେଖି ଅଳ୍ପ ଦେଖି ଗୋଟେ ବିଜେପି କମିଟି ବାଡୁଛି ଆମେ ଯାଇ ବିଜେପି ବାଡୁଛି ସେ ପୁରା ଗାଡି ସେଟ ଗୋଟେ ବାଡୁଛି କ୍ୟାଟ ପୁରା
काली डीजे ऑफिस घेरा देखिछन
काली कोउथरे पढन काली
काली डीजे ऑफिस पूरा प्रॉपर घेरे होई
ठीक अछि
बीजेपी
एबे बीजेपी के माने खबर आ हल्ला
नहीं करे दरकार ये भी बहुत करप्ट
हां संते विरोध ए लपिना देख रही
बहुत करप्ट काम
काली ये आस्ते पुलिस तो ये
डीजे न था लगा तार पोस्ट लगे थिला
से लोक भी टिके ओडिया कहूची ये पूरा 17 वर्ष हम ओडिया लोक काटी ओडिया
ଆପଣ ଆଳୁଚପ ଫାଳୁଚପ ଛାଣିକି ଗଲେ
यूट्यूब देखंदो यूट्यूब जिबे एटे एनआईटी ए मार दे एनआईटी लाइव भी चल
तो चल देख ना
लाइव भी देखबे
नहीं ता वीडियो डाउनलोड करके बेटर हो जाता भलो जिंस अपन तो क्लास कोले हेल्प होना और तो जदी अपन साइंस कलेक्शन न करी
देखला पर जोटा देखियो जोटा आसियो
डाउनलोड ऑप्शन दो
डाउनलोड ऑप्शन ना आपर आईडी थियो ना आईडी आसियो न तो नॉर्मल डाउनलोड कर ले सपोज एट देखियो
डायरेक्ट देखियो आ डाउनलोड कर
डाउनलोड करियो ना एटा
करले ना
हां एटा देखो डाउनलोड दिस वीडियो
One place,
आईडी थिलो
very comfortable environment in the mostly the stage. Here all the ambient conditions or room conditions can be maintained. But optical fiber is deep and it faces all types of
भलो ठीक अछि हम मारी बड़ी लेखुती आईडिया नथला नले सुनिया
Hello.
ସବୁ ଯା ଛାଡୁ ନା ଏ ପୁରା
Hello.
क्वेश्चन
हम in the class थोड़ा 5 मिनट के बाद बात करते हैं
आई एम इन द क्लास
मान ସାର୍
सेटा क्लास के लगा था सर नहीं है
It can be that factor, but fiber it is not, it is hardly affected by that factor.
Okay, thank you.
Any question from other knowledge center?
हेलो गुड मॉर्निंग सर
Morning.
एटा देखो ना एटा मोर आसी
Sir, I am Navakrishna from Barampur, Odisha.
Not final session.
Hello, sir, I am from Gate College.
लाइव शो भी चल लाइव शो भी चल
Yeah.
लाइव पे देखियो
Sir, actually, I have the doubts in jitter. You said that when the length is increased in the diagram, the jitter is more. What is the actual meaning of jitter, sir? Jitter, I cannot get that.
No, basically jitter is related to not length. Then in case of when we increase the length, the increase in jitter will be because of the fiber itself. But what is jitter increase is related to data rate. If you increase the data rate, then jitter will be affected.
इसलिए इंटरेस्टिंग है अदरवाइज
Sir, actually, what is the meaning?
हाई और सब नहीं तब डाउनलोड पे रखी दा भलो जिंस
मॉल दीटा है आ चारटा करे
करे
So it goes in different directions. That is what is called as scattering.
Yes.
And dispersion is basically what we have light. Light, if you have ornament light, it comprising of 7 wavelengths. So light split up into 7 colors. That is called dispersion.
Okay.
So scattering is a loss
कौन
in different technology.
मोर क्वेश्चन
Thank you, sir. And we will try to fulfill the
Sir, welcome.
from this program.
आमा से
Thank you for the introduction. I go to the next center. And that is
लेके
Gandhi Academy of Technology and Engineering, Rampur, Odisha. That is by Dr. Mr. Deepan Chandra Mohanty. That is the program. We are invited program coordinator Professor Deepan Chandra Mohanty. This morning I'm audible at your place.
कौन फालतू ही
फास्ट डेट है ना एटा
फास्ट रे
अपन मत ले
Thank
Thank you.
Yeah. That you continue.
I am from here, Baram. So I first of all I give you many thanks for this program because this is the technology that is required highly for our engineering faculty members as well as for the technology that has been developing day to day as we are communicating from our students with the communication subject is top technology that has been day to day advancing in our communication field. And as I am a communication teacher, I also introducing to our students of the advanced communication system that has been implemented day to day for the 1G, 2G, 3G, and 4G, like the advanced 5G communication system. And this optical fiber is what requirement for the students as they know the communication, but how the communication system that has been implemented by the systems by using the optical fiber system and the fundamental requirements and the fundamental requirement for their understanding. This is highly essential for this program. So I am inviting all my branches and also inviting other periphery engineering college staffs for their benefit. And we have also arranged around minimum staffs. So I give you thanks for this program. Okay.
Thank you very much.
The Jana sir category. Jana sir category. Thank you.
এটা এটি জায়গা এটা আইটেম খুললে ডাউনলোড যদি আইটেম নথিও মানে অলরেডি ডাউনলোড
And then the School of Computing Science and
Another one, more to say. Another happening.
এটা লাইভ তো চলছে
Another which
the School of Computing Science
Asnani.
Two questions. Really thinking.
optical almost theory tonic
Sir, आपने तो डाउनलोड कर अपना ले जाना था कर
चौधरा कौन था बिल्कुल लग जा
আগে যেটা দরকার সে সেটা রাখতে আসলে
ना ऐड कैंसिल मेमो जो
कॉलेज रो जो ये पर्पस है सिंपल
सर एक्चुअली दो ब्रांच में सब कर लो हम जॉन
স্যার ফ্রম সাউন্ড অফ করে ফার্স্ট
लैपटॉप ही चलता है ना,
नहीं सर आज ये माइक यूज कर रहे हैं।
माइक है तो इसको क्या
नहीं सर बस ये सेंसिटिव है कैप्सूल।
अच्छा कर लेते हैं। So good morning all the participants at different knowledge centers. I hope you are back at your places. So we are going to start the next session, and this is the of course last academic session also. So after this session we will conduct the valediction and session, and of course during that part we will also discuss some other issues. So this session as per our schedule, this is on OFC networks and radio on fiber. So for this session we have with us Dr. Baljeet Kaur. She is Assistant Professor, Department of Electronics and Communication Engineering, Guru Nanak Dev Engineering College, Ludhiana. Her area of specialization is optical communication. Dr. Baljeet recently got her PhD in the area of working in the area of optical communication, specifically on OFC networks and radio on fiber. She is ME from BIT Misra, Ranchi in 2004, and completed her PhD from NIT Hamirpur in this specific area in 2014. She has published more than 10 papers in journals and more than 25 papers in conferences. She has also attended many faculty development program or short-term training program. Also conducted these program at her place at Guru Nanak Dev University, Guru Nanak Dev Engineering College. Recently in April, she was very enthusiastic to conduct one program in the area of optical fiber communication. So in association with NITER and GND Ludhiana, we conducted this program. That's how we come in contact with during that period only. And I find she is very enthusiastic in working in this area. And OFC network and radio and fiber, these are very important topic now in optical fiber communication, because now it is the time of networking. All institutions, all companies, all countries, now they are all going for networking. So OFC network are only requirement to fulfill this ever increasing demand. She is also member of board of studies of EC department and member of library committee also. She is member Communication Society of IEEE, member Institute of Electrical and Electronics Engineer, IEEE, also live member of Indian Society of Technical Education. I am very thankful to Dr. Baljeet for accepting my invitation and be with us for sharing her experiences. She have traveled from Ludhiana to Chandigarh to deliver this lecture, and I hope during this interaction session you will learn a lot about these OFC networks, different type of, and how these network can be used for multiple applications. It is not that our OFC network, they should be dedicated only for optical carrier of optical frequency. We should be able to put all type of services on these network, and during this session she will interact on all these issues. So I request Dr. Baljeet to start the session, please.
Thank you, sir. First of all, I would like to thank Dr. B.C. Chaudhary for giving me this opportunity. Thank you, sir, for calling me. And my today's topic is OFC networks. In OFC networks, I will cover 3 topics: passive optical network, then GPON, gigabit passive optical networks, and ROF, radio on fiber. It is also called as radio over fiber. So first, I will cover PON and GPON, passive optical network, and gigabit passive optical network. So what is the motivation behind passive optical network? Why we need passive optical network? So we all know there is increased dependency on internet services. Day by day, internet users are increasing. Traffic increased by more than 100% in a year, and every minute more than 12 million email messages move across the internet, and about 500,000 voicemail messages we are doing through the internet. So more than 100 million people, they log on to the internet in a day to access various types of services. So digital subscriber lines and cable modems, they cannot keep with such a high demand. So some new data centric solution is required, and that solution is achieved with the passive optical network. Most network operators have come to the realization that new data centric solution is necessary. Such a technology would be optimized for the IP data traffic. So passive optical network, PON, it is seen by the many researchers as an attractive solution to this problem. So with the use of only DSL and cable modems, we can achieve only the distance of 5.5 kilometer. So that is not the sufficient distance, and data rates for internet what we want, it is also not sufficient with the use of only DSL and cable modems. So we need some other technology, that is some other network, passive optical network. So with the use of passive optical network, we can achieve distance of over 20 kilometers. So that is sufficient. Now, where passive optical network is required, actually where we want passive optical network. So basically we have divided total networks in three parts. First is local area network, second is access network, and third is core networks. So in local area networks, we are already using copper cable, and that is with the use of copper cable, we can get high data rates over short distances. So next is core networks. In core networks, we are using fiber optical cables. So with the use of fiber cables, we can get high data rates over long distances. So our main weak spot is the access network. Actually, in access network, what we want, optical fiber cable. So with the use of optical fiber cable in the access network, also we can get high data rates over the long distances, over 20 kilometers of distance. For the access network, this 20 kilometer is the sufficient distance. So what is access network? It is the telecommunication networks that connect subscribers to their end providers. So basically this is the communication between the central office to the end users. We want to get high data rates at the subscriber points at the end users. So for that purpose, we are using passive optical networks. So basically the logical ways to deploy optical fiber in local access networks are, first is point-to-point network, second is curved switch network, and third is passive optical network. Now here through the figure A and B and C, we have compared these three type of networks. So in first network, we can see point-to-point network between the central office and end premises, or you can say between the central offices and end users, we have total 32 fibers, and for 32 fibers we need total 64 transceivers, 32 at the central office and 32 at the end users. So 64 transceivers are required for the point-to-point network. Now second is curved switch network. So in curved switch network, we need only one fiber between central office to curved switch, but total 66 transceivers are required. 64 from curved switch to end users and 2 from central offices to curved switch. But in case of passive optical network, we can see there is only requirement of 33 transceivers and one fiber line. So if you do the comparison of all these three types of network, so cost is minimum in case of passive optical network due to less number of transceivers. So passive optical network is best choice among all these three networks. That's why we have chosen passive optical network. Now the basic architecture of the PON, passive optical network. So passive optical network is basically divided into three parts. First is OLT, then ODN, optical distribution line, and third is ONU, optical network unit. So all the active elements, they are only present at the OLT, optical line terminal, and at ONU, optical network unit. So there is no active element in the access part, means from central office to end users. From central office to end users, what we are using? We are using only splitter. So what is the function of splitter? It will split the signal into different end users, different and premises. So PON consists of a central office node called optical line terminal, one or more user nodes called optical network units or optical network terminals, and fibers and splitters between them called optical distribution networks. PONs are called passive because other than at the central office and subscriber endpoints, there are no active elements between the access network. Hence, due to the lack of active elements in the light path in the architecture of PON, it is very simple, cost effective, and it offers virtually unlimited bandwidth to the subscriber that is not possible with other type of access network. So PON is the best choice among all. Now PON overview. Basically PON, it is used to the fiber to the curb, fiber to the building, fiber to the home, means where we required actually fiber. If we required fiber at the curb, so it is called FTTC, fiber to the curb. If it is required to the building, so it is called fiber to the building. If it is required to the home, so it is called fiber to the home. So types of PON, basically PONs are divided into 4 types of networks. First is ATM PON. In ATM PON, we are using asynchronous transfer mode, and this is the first passive optical network, and data rate is only from 54 megabit per second to 155 megabit per second. Second, B PON, data rate is 622 megabit per second. Third is IEEE PON, EPON. It is based on the standard IEEE 802.3AH, and it is completed in 2004 as a part of First Mile project. Data rate is 1.25 gigabit per second in both downstream. Downstream is from OLT to ONU, and upstream is from ONU to OLT, and data rate is fixed, that is 1.25 gigabit per second, and it is based on totally Ethernet protocol. So now research is basically going on EPON and GPON. So next is GPON, because with these 2 types of network we can get high data rate. So GPON, for GPON standard is ITU-T G.984, and it uses 2.5 gigabit per second in downstream direction and 1.25 gigabit per second in upstream direction. Basically it is used GEM, encapsulation transfer mode, and GPON is today's front runner in Europe, and EPON, it is deployed already in Asia. So current access technologies, this is the comparison for different types of access technologies. What we are using: ADSL, VDSL, HFC, Wi-Fi, WiMAX, BPON, EPON and GPON. So in all ADSL, VDSL, HFC, we are using copper cable, and data rate you can see it is highest in case of EPON and GPON. With EPON, it is already we have seen about 1.25 gigabit per second in both upstream and downstream direction, and we with the GPON we can achieve up to 2.5 gigabit per second. So nowadays all research it is going on EPON and GPON, and we are using these 2 types of networks only. Now this is the comparison between EPON and GPON. So standard we have already discussed. So framing, in case of EPON it is Ethernet, in case of GPON it is encapsulation mode, GEM. Maximum bandwidth we have already seen. Data rate it is 1.25, and it is 2.5 and 1.25 in case of GPON. Bandwidth per user in case of EPON it is 30 to 60 megabit per second, and in case of GPON it is 40 to 80 megabit per second. And broadband efficiency 92% in case of EPON, 72% in case of GPON. So basically EPON is used for multi-services and for different fiber to the homes, fiber to the curb, or fiber to the building premises, and this is GPON is pure data service. Maturity, in case of EPON it is large vendors involved, and in case of GPON small vendors involved. So this is the comparison of EPON and GPON. Now PON advantages. So we all know we are using PON only to get the high data rate. With the use of passive optical network we can get high data rate. So this is the first advantage. Second is longer physical reach. So with the use of passive optical network, we can reach up to the distance of 20 kilometers. And equipment sharing, electrical to optical components and electrical devices at the central office are shared amongst a large number of subscribers. Reduced maintenance cost because there is no active element between the access network. So we can say cost is reduced in case of PON network. Now, current status of PON, passive optical network. So we know in passive optical, generally what we are doing, we are transmitting signal from OLT, optical line terminal, to ONU, optical network unit, similarly from all ONUs to OLT. So if we are transmitting signal in downstream direction, means only OLT can send data to different ONUs. So if only ONT is sending the data, so no danger of collision in downstream direction. But if we see the case of upstream direction, in upstream direction, all your ONUs are sending data to OLT. So we need some collision mechanism in case of upstream direction. So in upstream traffic, all ONUs can send data, need collision prevention mechanism. Ethernet offers CSMA CD. It works but does not avoid collision and total waste of bandwidth. So what we actually require? We require some multiple access techniques. So it divides the physical media into multiple virtual medias. Offer each ONU a separate channel. So there are different types of multiplexing techniques. First is time division multiplexing, TDM. Second, wavelength division multiplexing, WDM. And third is the combination of these two types of multiplexing techniques, that is WDM plus DDM. So nowadays all research, generally you can see it is based on the combination of WDM and TDM, basically in PON networks. This is the basic architecture for these three types of multiplexing techniques: TDM, WDM and hybrid WDM, TDM PON. So first we will discuss TDM PON, that is time division multiplexing passive optical network. So in TDM PON, remote node containing optical power splitters connects OLT to many ONUs. So what we are doing in TDM PON, there is optical splitter. It will divide signal from OLT to different ONUs. So basically, a splitter is used for dividing different signals, right? Now, second, in downstream direction, all the broadcasted information is received at every ONU through splitter. So splitter will split the signal and it will receive by the ONU. Now at the ONU, the relevant packet with correct address level is processed and all other data is discarded. So we can see in first user, in add user 1, only first packet is received, other two packets are discarded. Similarly in ONU 2, second is received, and in ONU 3, third packet is received. So accordingly we can receive the required packet at the ONU, different ONUs in case of TDM PON. Now disadvantages of TDM PON. So shared traffic structure is a major roadblock for the future development of TDM PON. Here we are using shared traffic. So at ONU only we are discarding the packet, but till the ONU all packets will come. Okay? Second, furthermore, the use of optical power splitter leads to security issue and significant power loss. What we are using in the access network, we are using the optical splitter. So with the use of optical splitter, it will we can get maximum power loss if we are using the optical splitter at the access point. So in case of, if in terms of insertion loss, we will talk. So with the use of optical splitter 1:32 optical splitter, 17 dB insertion loss is there if you are using optical splitter 1:32 optical splitter. So this all are the disadvantages of TDM PON. Second is WDM PON, wavelength division multiplexing PON. So WDM PON is a promising solution to improve the performance such as bandwidth, security and power loss. Signals are coded on separate wavelength channel. So here separate wavelength is used for the different separate ONUs. And wavelength splitting, it is done by AWG. What is AWG? It is arrayed waveguide grading. So for the wavelength separation, here which component we are using? AWG, arrayed waveguide grading. So reduced insertion loss. If in place of optical splitter we are using AWG, so it will give the reduced insertion loss. It is only 3 to 5 dB. But in case of splitter, it was nearly 15 dB, 15 to 17 dB. This approach creates a point-to-point link where a dedicated wavelength channel is reserved between the OLT and each ONU. Each ONU can operate at the full bit rate of its own wavelength because particular wavelength is assigned to a particular ONU. Okay? And there are some disadvantages also in case of WDM PON. Cost. Each user requires its own dedicated transceiver at the OLT. Obviously, if particular wavelength is fixed for a particular ONU, so some dedicated transceiver receiver is required at the ONU and at the OLT. So it will increase the cost. Second, the AWG filter is more expensive than the splitter used with GPON, EPON and BPON. So if you are using AWG filter in place of splitter, so it is also increase the cost. So cost is the major drawback with the use of WDM PON networks. Now hybrid WDM TDM PON. What we are doing in hybrid, we are using both TDM as well as WDM techniques. So PON combining both WDM and TDM technologies called hybrid PON is the most promising candidate for next generation optical access networks. High split ratio means large number of users is provided by TDM PONs and large number of wavelengths and high capacity per wavelength offered by WDM PON. So with the use of this hybrid network, we can get large number of users as well as large number of wavelengths and high capacity. So this all we can achieve with the use of hybrid PON. Now types of hybrid PON. We have two types of hybrid PONs. First is static WDM TDM PON and second is dynamic WDM TDM PON. So as name implies, static means there is fixed wavelength for a particular ONU. But in case of dynamic, we can change the wavelength. So each wavelength, in case of static WDM TDM PON, each wavelength can be shared by several ONUs and the wavelength assigned to an ONU remain unchanged from installation until disconnection. So in this case, wavelength is fixed. Now dynamic ONU wavelength assignment can be dynamically changed during communication or during operation. So we can see if we compare these two types of static and dynamic hybrid PON. So obviously dynamic PON is more advantageous than the static hybrid PON. Now future trends, challenges to WDM and hybrid PON. Relatively high cost of the WDM component. If you are using WDM or we can say hybrid PON, where also WDM PON is used. So in this case, cost is very high because we are using WDM components. Second, in a WDM PON, Each OLT and ONU needs a different wavelength for downstream and upstream transmission, introducing a serious operational and economical issue. Many research efforts are focused on to realize the colorless ONU, that is wavelength independent ONU, so to achieve low cost transceiver. So if we will use colorless ONU, means this ONU will independent of the wavelength. We can design ONU for any wavelength. So in this case, we can reduce the cost of the system. Cost is our major issue if we design this hybrid PON. So with the use of colorless ONU, we can reduce the cost of the system. Now colorless ONU, a colorless ONU will support all wavelength channels, reducing cost through volume production of one component. Therefore, ONU must contain tunable transmitter and receiver devices, because if we use tunable device at the transmitter and receiver side, so we can tune for any wavelength. A tunable filter is used to select or tune to any of the downstream wavelengths, and tunable laser is used to provide colorless upstream direction. So at the downstream direction we need tunable laser, and at the upstream direction we need tunable filter if we design colorless ONU. Hybrid TWDM PON or wireless access network. Now what we want to combine PON with some wireless network. Wireless and optical technologies playing a crucial role in modern access network. So if we combine this optical with wireless network, so we can get high data rates for the end users. So service operators are looking for optical and wireless integration. So to combine WTDM PONs with emerging broadband wireless access technologies such as WiMAX and Wi-Fi. Complementary features, that is high capacity provided by optical network and mobility offered by wireless network, are exploited so to enable the delivery of quad play services. Quad play services, triple play services, we all know video, data and voice. Now in case of quad play, we need mobility also. Okay? Data we are transmitting video and voice signals, and also what we want mobility. So this we can achieve with the combining of both optical and wireless network. So we can see the architecture. In this case, the optical backhaul is a hybrid PON which contains OLT at central offices, single mode fiber, remote nodes and multiple access points. This all under the optical premises. Now in case of wireless, the wireless front end consists of widespread access points and access points to penetrate numerous wireless end users. So this is the wireless end user. This is the combination of both optical and wireless network. Now what is the conclusion? WDM and hybrid technology offers a great promise to meet next generation PON requirement and have several advantages over TDM PONs. That's why we are using nowadays WDM and hybrid technology. But there are several disadvantages such as high cost of ONUs for point-to-point links in WDM PON. So future research efforts devoted to solve the issue will provide a way out of this. So this all are the related publications which I have discussed. So and references it is given. You can see in detail if you will refer all these references. It is basically for WDM TDM PON, and in this we can also see hybrid PONs, right? This all are the references. Now next OFC network is radio over fiber, radio on fiber or radio over fiber. So basically, as name implies, radio over fiber. What we want to transmit radio signal through the optical fiber. So why we need radio signal, why we transmit radio signal? Because what we want to combine optical with wireless. So if we use wireless network, so for wireless network, what we need? Radio frequency. So first we modulate radio signal from the transmitter, and from transmitter means from OLT, yeah, with the use of OLT, and we will receive the signal and demodulate at the wireless network to provide the mobility. Now radio over fiber, to meet the explosive demands of high capacity and broadband wireless access, modern cell based wireless networks have trends, that is continuous increase in the number of cells and utilization of higher frequency bands. So what we need nowadays, increase in number of cells, and we need higher frequency bands. This we can achieve only with the use of radio over fiber networks. It leads to a large number of base stations to be deployed. Therefore, cost-effective base station deployment is a key to success in the market. What we need, if we are increasing the number of users. So with the increase of number of users, what we are increasing? We are increasing number of base stations. So cost-effective base station is our main requirement, right? In order to reduce the system cost, radio over fiber has been proposed, since it provides functionally simple base stations that are interconnected to a central control station via an optical fiber. So what is the basic function of radio over fiber? ROF based on radio over fiber, that refers to a technology that use light to modulate electrical signal, radio signal, and transmit it over the optical fiber link to distribute radio signals from central location to the remote stations. So what we want, actually we want to distribute radio signals up to the end premises, to the subscriber, to the end users. So to distribute radio signals to the end user, we need radio over fiber, right? At the receiving end, RF signal is demodulated and transmitted to the corresponding wireless user. So in this basic architecture, we can see control system, CS, and then base station. So in base station, basically electrical to optical and optical to electrical converter is used in base station. It will transmit radio signal and it is received by the mobile stations. So RF is an analog optical link transmitted modulated RF signals. It serves to transmit the RF signals down and uplink, that is to and from central of stations to the base stations. It is also called the radio ports, because here what we are using radio signals. So this all are basically radio ports. Types of cellular networks. So according to the different sizes, this cellular networks, it is divided into three types of cells: macrocells, microcells, and picocells. So this all are basically in terms of different radius of cells. If there are more number of users, so we will use small cells. If less number of users, so we will use large cell. So macrocell, for macrocell, the radius distance for macrocell, it is 16 to 48 kilometer. This network uses fewer sectors. Original switching center controls interconnection with PSTN. In case of microcell, radius is 200 meter to 1 kilometer. To support growing number of mobile users and to support frequency reuse increase, the cells may be subdivided into smaller units called microcells. So microcells increase capacity and also reduce power consumption and size of handset devices. Now next is picocell. Picocell means radius will be very less. It is only from 4 to 200 meters. Is a small cellular base station typically covering a small areas like in building offices, shopping malls, train stations, stock exchanges, etc. In cellular networks, picocells are typically used to extend coverage to indoor areas where outdoor signals do not reach well, or to add network capacity in areas with very dense phone uses, such as train stations or stadiums. So picocells provide coverage and capacity in areas which are difficult or expensive to reach with the use of macrocells. Now the benefits of using ROF technology. In a ROF system, most of the signal processing, means you can say coding, multiplexing, radio frequency generation, modulation, this all, it is done only at the central office, which makes the base station cost effective. So RF technique has the potentiality for the backbone of the wireless access network. Such architecture can give several advantages, such as reduced complexity. At the antenna site, radio carriers can be allocated dynamically to different antenna sites, transparency and scalability. So this all are the advantages of using RF technology. Applications in cellular network, we are using satellite communication, video distribution system, mobile, broadband services, and in wireless LAN. Now, recent research, it is going on basically with the merging of these two types of networks. So here what we are merging WDM PON, WDM passive optical network with the radio over fiber ROF network. So mobile traffic is rapidly increasing to access variety of services, and their access methods diversifies in various types of radio air interfaces. This trend requires the more and more efficient use of radio frequency and the reduction of radio cell size for wireless access. So what we want more number of users, more bandwidth, and as well as what we want mobility also. So this two things we can achieve with the combining, with the merging of WDM PON with ROF network. So WDM PON is investigated for its large data bandwidth, enhanced security and scalability to support several local subscribers. Integrating a millimeter wave RF system with a WDM PON, that is WDM RF PON, is a very attractive solution to significantly increase the overall capacity and coverage area of the RF network. So this is our main aim, to combine these two types of networks, that is WDM PON with the radio over fiber network. So this is the basic simulation of WDM RF PON model. Simulation is done in the OptiSystem software, and version 10 is used for this simulation. Here what we can say, at the transmitter side, this transmitter side what we are using OLT network, optical line terminal, and at the receiver side different ONUs are connected. So in OLT side, what we are doing, for the transmission of radio signal, we are using AM modulator, and the frequency for the AM modulator is here 15 gigahertz. So this radio frequency, it is transmitted from OLT to ONU. So here AM modulator, it will transmit radio signal from the OLT side, and at OLU side what we are using, AM demodulator to detect the radio signal at the ONU, and then it will distribute to different end users. So this is the basic model designed in OptiSystem software, and here WDM MUX 2:1 WDM MUX, it will combine two types of signals for the two optical carrier frequency. So in first case, first laser, what we are using 193.1 terahertz, and for this second channel what we are using 193.2 terahertz channel frequency. Now this is the design inside ONU1. So here we are using WDM demux. So it will again distribute this signal to the different end users. And what we are using, AM demodulator to extract the radio signal which is transmitted from the OLTU. Now this is design parameters: downstream bitrate, upstream bitrate, wavelength, traffic mode, modulation format, and power. What we had taken, insertion loss, length, that is fixed, it is 20 kilometer. Dispersion is 16.75 picosecond per nanometer per kilometer, and dispersion slope attenuation only, it is 0.2 dB per kilometer minimum attenuation, and insertion loss is only 1.5 dB. So this all are the design parameters which we have taken for the designing of, for the simulation of this system. Now we can see the result. So first radio frequency at 15 gigahertz and first channel carrier frequency at 193.1 terahertz. So this is for the first channel. Similarly, for the second channel radio frequency at 15 gigahertz and second channel carrier frequency at 193.2 terahertz. So there is a difference of 100 gigahertz between these two channels. In first, what we have taken 193.1 terahertz, and for the second, what we have taken 193.2 terahertz. So these two we can see after combining. For the combination, what we are using, WDM mux. So this WDM mux will combine these two types of channel frequency for the further transmission of the signal. Now results. For the analysis of results, what we will use, eye diagram. So eye diagram we can see, I think you have already studied about the eye diagram, Q factor, bit error rate. So in first case, we are seeing Q factor, it is only 6.12, and bit error rate, it is 10 to the power minus 9. So for second, it is 6.52 and bit error rate is minus 11. So in optical communication, we know the acceptable BER, bit error rate, it should be in the power of minus 9. So that we are achieving with the designing of this WDM RF PON signal. Now conclusion. After this simulation, what we have concluded, this simulation model for PON has been simulated by taking 20 kilometer of fiber length, that is sufficient for different applications of this technology. So 20 kilometer distance, what we have taken, that is sufficient if we design this system. Now second, it shows that various customer application requirements can be satisfied and services can be prioritized and granted to the customer, and now it is easy for the end user to get the high data rate if we are using this type of networks. The use of simulation helps us to focus on identifying the right design and making decision regarding how we can deploy this system actually and without getting bogged to the technology debate. Now, first what we have done, we have designed the basic WDM PON RF model. Now, with the use of this model, we have achieved the bit error rate up to 10 to the power minus 9. So what we want, we further want to increase the performance of the system. So if we want to increase the performance of the system, so first for the increase of performance, what we are using here, we are using square root model. So what is a square root model? In the design of WDM RF PON link, the optical receiver, what it will do, it will receive the optical signal and again it will convert optical signal into the electrical form, right? So if we are using pin photodetector, pin photodiode at the receiver, so this will detect the incoming optical signal and it performs the modulus square operation. So IRX, you can see it is a square of E in. What is E in? E in is the input optical field at the receiver, and IRX is the detected electrical signal, electrical current. So what we are seeing, if we are transmitting E in input power and what we are getting, square of this power. So with this all intersymbol interferences, or you can say, means all optical effects, linear and non-linear, it will double with the use of optical receiver, this receiver. So what we want, we have designed square root model filter. So what it will do, it will square root all the non-linear effects, all the effects which are squaring through the use of this optical receiver device. So a square root transfer function module is proposed and it is placed after the photodiode. It compensates the square law characteristics for improving the performance of the linear equalizer. So this square root filter, it is designed with the use of MATLAB software and it is placed after the photodetector, after pin photodetector, right? So we can see this MATLAB script. With the use of this MATLAB script, it will take the signal and square root the signal, and then again it will transmit the signal to the filter. So basically what we are doing, only square rooting the signal, electrical signal. Now this is the design. Again it is done in OptiSystem software, and here again what we are using, total 8 ONUs at the receiver side, and we are transmitting this signal to the different end premises. So here after photodetector, what we are using, MATLAB component, we can see in the diagram. So in this diagram, after the photodetector, this MATLAB component is used. So parameters, design parameters, what we have taken, responsibility, dark current, electrical filter type, bandwidth of the electrical filter, and gain of electrical amplifier. This is fixed for the designing of the system, right? Now eye diagram. So we can compare previously without the use of square root filter, it was only 6.12 Q factor, and bit error rate, it was only in the range of 10 to the power minus 9. Now if we are using square root filter after photodiode, so with the use of this we can increase Q factor as well as we can reduce bit error rate. So this, in terms of bit error rate, we can see the performance of the system can be increased 4 times. In first case it was only 10 to the power minus 9, and in second case it is 10 to the power minus 36. So this much of improvement we can get with the use of square root filter. Second, for second channel is of only 193.2 terahertz. For this again we are getting 4 times improvement in terms of BER. If we compare the signal power, so signal power is again increased if we use square root module. So it is 4.675 dBm with a square root module. On without square root module, it is only minus 20.563, and for OLT it is minus 47.118, and without square root module it is minus 84.896. So this much of improvement we can achieve with the use of SRM. If we compare Q factor for different fiber lengths, so again we can see the comparison without square root module and with the square root module. So with the square root module it is improved. Now in terms of different optical power, so for the designing of WDM ROF PON link, what optical power we have taken, it was 0 dBm. If now we will change the optical power for different optical power, we can also compare the result. So here input for different input powers with and without SRM, with SRM we can see there is improvement as compared to without SRM. So what is the conclusion? In this simulation, SRM is used at the receiver side, which plays an important role to enhance the performance of the WDM ROF PON link. So improvement in the performance, it has been reported 4 times in terms of BER for successful transmission over the distance of 20 km. So here distance is fixed, it is 20 km. Results are also compared for different fiber lengths or for different input powers with and without SRM, and we can see with SRM there is improvement as compared to without SRM. So in this way we can increase the performance of the system. Now second is performance is again enhanced with the use of optical SSB transmitter, optical single sideband transmission. So what is SSB transmission? We all know. In case of DSB double sideband, now what we are transmitting single sideband. So with the use of single sideband, we are reducing the power, right? If we reduce the power, so all non-linear effects will reduce, and we can see this parameter chromatic dispersion, which you have already studied. So this effect is also reduced if we reduce the power of the signal. So fiber chromatic dispersion is one of the factors limiting transmission distance in optical high-speed transmission system. So if we reduce chromatic dispersion, so with the reduction of chromatic dispersion, we can increase the distance, right? And for a single mode laser, the symmetrical sidebands are created on optical carrier. Due to fiber chromatic dispersion, a relative phase shift is added to this sideband. So basically here what we are doing, we are converting DSB signal into SSB, double sideband signals into single sideband signals. So this is the single sideband generation, mathematical representation of single sideband generation. Here what we are using dual electrode Mach Zehnder modulator. So in dual electrode Mach Zehnder modulator, in first case directly we are transmitting electrical signal, and in second port we are giving electrical signal with pi/2 phase shift. So this pi/2 phase shift, it will create the single sideband, right? So this is the basic architecture for the single sideband generation. We can see ONU generation of SSB at the OLT side. OLT side, basically we want SSB generation, right? Because OLT, optical line terminal, it is transmitting the signal from OLT to the ONU, and from here only what we are transmitting the double sideband. So basically this single sideband generation where we require at OLT side. So to generate optical single sideband signal, input is applied to both the electrodes of the Mach Zehnder modulator. In one electrode it will come directly, and second with pi/2 phase shift. So after this Mach Zehnder modulator, we can see there is the generation of single sideband. Design inside first ONU. Here we are using total 8 number. So design inside first ONU. Here we are using WDM demux. It will again divide the signal, and then for the transmission of the radio frequency, for the reception of the radio frequency, what we are using AM demodulators. Now to see the performance of the receiver, here what we are using 3R regenerators and BER analyzer to get the eye diagram. So this is the result. Here we are using total 5 channels for different wavelengths, right? And the wavelength spacing is 0.8 nanometer. Okay? In terms of frequency, what we can say, it is 193.1 terahertz, 193.2, 193.34 like that, 100 gigahertz. And in terms of wavelength, it is 0.8 nanometer. So this input power, what we are using here, only 0 dBm. That is sufficient. So we can compare the result. In first case, only it is optical DSB double sideband transmission. Okay? In this case, the BER, it is 10 to the power -9. And second case, optical SSB, optical single sideband without square root module. And third case, optical single sideband with square root module. In third case, what we are doing? We are converting optical double sideband into single sideband. Again, what we are using? We are using square root module at the receiver. Square root module, it will use at the receiver only, means after photodiode. Okay? So we can see the comparison in terms of bit error rate. First case, it was only 10 to the power minus 9. For second, 10 to the power minus 27. And for the third case, it is 10 to the power minus 54. So with the use of, if we are transmit optical single sideband, so in terms of Q factor improvement, it is seen 67% as compared to optical DSB. And again, if we use square root module, so in terms of Q factor, improvement is seen 43%. So this much of improvement we can get with the use of these two, SSB transmission and square root module, right? So again, analysis is done, Q factor versus input power of SSB. If we change different input power, if we'll take, so again different Q factors we can achieve at the receiver. So this is the comparison, SSB without SRM and SSB with SRM. So obviously SSB with SRM is good as compared to SSB without SRM. So conclusion again, in this simulation and technique for the generation of optical SSB transmission with carrier for WDM PON with RF optical network is proposed. The separation of 5 dB in the carrier and 10 dB in the sidebands has been shown. So what separation we are making here? Only 5 dB for the carrier and 10 dB for the sidebands. So for the successful transmission of optical SSB signal, improvement in the performance in terms of Q factor, it has been reported 67% as compared to optical DSB, and again it is enhanced by 43% with the use of square root module. So this much of improvement we can get. So this all are the related publications. I've already published paper in optic. It was based on WDM PON with ROF with the use of a square root module, without a square root module with the transmission of SSB signal, and what we can again add optical vestigial sideband. Here I am not explaining this optical VSB. We can compare the result for the optical DSB transmitter, for optical SSB, for optical VSB, and which one is good, right? And again we can add some square root module. And next I have taken DCF and FBG. DCF, dispersion compensating fiber, FBG, fiber break grading. This also you can add. So all research, it is basically going on this different types of transmission, and for compensating this non-linearity, what we are using, DCF and FBG. So in this way we can improve the performance of any system. This was only for the WDM RF network. For the performance of any other network also we can use this type of transmission and this types of component, DCF and FBG, right? So this all are the references which we can use. Thank you. Query? Any query?
Thank you, Dr. Baljit, for giving very important and very illustrative information on different type of OFC network, PON and GPON, and all these are now at the stage of development. In somewhere they are also used. So, and further she elaborated how we can utilize different type of simulations or different type of some software. We can create different type of devices to improve the system, because you find she has shown how the optic system, different examples where with the square root, with the sideband suppression, how we can improve the capacity of the system, how we can minimize the nonlinear effects, all these which create the problem in our communication system. So you can you can utilize all different techniques. You can propose other things using these simulations. In fact, what I have discussed in the first session, it's a very good supplement to what or examples she has discussed. That's a very good supplement to what the simulation model, how they can be utilized for all these applications. So thank you, Dr. Baljit, for once again for sharing very, very important information, which is of course very, very useful for all our participants or for our teachers to discuss further for the improvement of the system. So now session is open for discussion. In case you have any queries, you are most welcome. Any query from classroom? Madam, aapka? So any query from our nodal centers?
Hello.
Hello.
Hello,
Hello.
madam. Good afternoon.
Hello, good afternoon, ma'am.
We are from the gate Perhampur.
Okay.
Ma'am, I want to know what type of filters are used to get OSSB from DSP in such high frequency ranges.
What type of
Filter.
filters?
To get OSSB from DSP.
This is to get DS.
Such stuff in high frequencies ranges to get SSB signal. So
Actually-
these are very high frequency range. So what type of filters we use here?
Basically, in the operating system software simulation, what filter I have used only low pass filter, Bessel filter. It is already available in the software, and any other type of filter you can also use, but the frequency which you have taken for the transmitter, that you have to choose for the receiver. So that is the only criteria.
Okay, madam. Device, what type of filters is used?
Here I have used Bessel filter for, yeah.
Okay, thank you.
Any other question from gate?
Hello.
Sir,
Hello. Sir, one more question, sir. First of all, I am going to give thanks to ma'am, Baljit ma'am.
Thank you, sir.
I am also using that Opti systems, and I did the project regarding the FWM, four-way mixing, sir. So when we are sending the signals through the fiber, definitely four-way mixing is coming.
Right,
So-
right.
Yes, so suppose two signals I am giving over the fiber.
Okay.
On the output sides, that is giving four signals. So two
Right.
main signal to another mixing signals, non-linear effect signals.
Okay.
The first question is whether the effects are going to be helpful for us or any disturbance that is taken as a disturbance signals.
Obviously, if you are transmitting two signal and receiving more signals, so it will degrade the performance of the system. So for improvement, what we are using here, I have used fiber brake grading. Fiber brake grading. So you can use two fiber brake gradings for the separation of the two signals which are generating. So you can fix the first channel frequency for the first fiber grading and second channel frequency for the second fiber grading. So also you can refer my paper I have published with the WDM PON ROF with the use of DCF and FBG. Here I have suppressed the four-wave mixing signals. You can refer this paper. Already it is given in related publications which I have published in Optic. So you can get an idea how you will remove this four-way mixing effect with the use of fiber brake grading.
Completely, we can remove that effect.
Not completely, but we can reduce the power of the signal which we will transmit. Completely, we cannot remove any effect. We can reduce, but we cannot remove completely.
Madam, till now I am using a different technology like circular polarization hybrid technologies to reduce the FWM effect. But
Right.
up to 80 to 85% it is reduced. If
Right.
if I want to reduce more, then what are the technologies I can use? The
So-
WDM.
In WDM techniques, generally what we are using this DCF and FBG. So with the use of circular polarization, you can reduce up to 82. Again, what we add FBG. You try to add this FBG component for the further reduction.
Can I try this? What you are saying? Explain that OSSB and square root filters.
Yeah, SSB means optical SSB. In this, what we are doing, we are generating the single sideband. Because what we are transmitting double sideband. So if we will consider both the carriers, so power will be more. If we reduce one sideband, so here we can reduce the power. So with the reduction of power, all non-linear effects will reduce. That's why what we are transmitting optical single sideband. And then again square root module, if we are using photodiode, so photodiode will square all the effects. So here if we use square root after photodiode, this square root module is designed in MATLAB. So this is the interfacing of OptiSystem software with MATLAB. So first we will implement this programming through the MATLAB software, and then we will interface with the OptiSystem. So it will square root all the nonlinear effects. So in this way also we can improve the performance of the system, any system. Also in your system you can use these two types, optical SSB transmission and square root module.
Okay, madam. Thank you, madam.
Hello, ma'am.
Hello.
Can we use any other type of filters in place of a square root filters?
Yes, you can use, there are different filters which are available in the OptiSystem software. So, but you have to see in with the use of which filter you can improve the performance. Suppose we have low pass filter, band pass filter, basis filter, this all are available in OptiSystem software, right? So you can use any filter and see your performance, in which your performance is coming good.
Okay, ma'am. Thank you.
Madam,
Yes.
hello.
Hello.
Madam,
Hello.
we need your contact email IDs.
Yes.
If you
Right.
are-
Baljeet
Yes.
Kaur, BALJEET
JEET
KAUR
KAUR
at GNDEC
at GNDEC
.ac.in.
.ac.
It is also
Okay, ma'am.
available in college website. You can see www.gndc.ac.in, college website.
Okay, madam. In further query, I can ask you.
Right. Most welcome. Most welcome. Thank you.
One question, madam, please.
Right.
As we have been implementing all the communication system and analog, digital, and mobile computing system, satellite communication system, RF, we are using radio frequencies. So, is it possible to replacing all the RF to ROF system, or it is already implemented?
It is already implemented. Means in case of if here what I have used AM modulator for the transmission of radio signal. So this modulator with we can use some digital techniques also to transmit this modulator, like QPSK, DPSK, different digital modulation we have already done.
So it is more effective than all the previous RF systems.
Yes, you can improve the performance with the comparison of this all different digital techniques.
So all these systems they have already replaced to convert to RF.
Actually, for different applications, if you will see digital transmission, QPSK, DPSK, what we are doing. So for different application, different transmission is good. Means we can't say this will be effective only for the one application. So it will vary according to application. So you can see also research papers. In different research papers, different modulation techniques are compared.
Yeah.
Okay. Right?
Okay, thank you, madam.
Welcome.
So any question from other nodal centers? और देखिए हजरत कोई किसी का है तो in case you have any questions you may ask.
Sir, एक question है please tell me the parameters or conditions under which different amplifiers can be used. Second question is dispersion compensator. What is the relation between the distance and width of the Broadband pulse in order to bring it back in normal form? From CTC, CD Jalandhar.
अभी कोई बैठा तो नहीं है ना?
No, through email,
हाँ.
Sir, text message.
we can reply through text.
चलिए बाद में देते हैं. अभी presently I hope now there is no question on related to this session, so we will close the session here. So again I request all the coordinators and to all the participants. Now our regarding this again our valediction session, our director, he will join the valediction session. Presently, he is in a lecture in connecting with some another in some another program. So he will be free around 1:45. So I all request all the local coordinator and all the participants, you can go have a break for lunch and come to your center maybe around before 2 o'clock, so that we can have a valediction session, we have an interaction session during this period. So and in that may continue for some time. So this is the opportunity that our director will be here for this valediction session. So again, I request all the participants and all the local coordinator to please manage to come just 10 minutes before 2 o'clock for this session. So thank you very much all the coordinators and participants for having patient listening to all these sessions, and we will close here. And good afternoon to all present in their at their places. So thank you very much once again.
Thank you, sir. Thank you.
Thank you, sir.
Hello. 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 Hello, sir. Hello. 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 So my voice is audible to you or not? Hello. 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 Audible to you or not? Wait a second. Okay.
पर प्रैक्टिकल लिख दो 100 रुपये 150 आप लिख दो कितना लिखे मेरे घर पे खाना आता है ये कब खत्म होगा?
बस इसको 2:15 इसके बाद आ जाती है।
अच्छा ठीक है। तुमने सुबह की फोटो ली?
नहीं सर मैं
तुम ऐसा क्या करते हो भाई?
सर मेरे पास मोबाइल नहीं है।
तो वो है ना वो हारून है क्या नाम है उसका हाफिज है क्या नाम है?
उसका भी चलता है।
मोबाइल जमा करवा लो सिंपल निकले भाई सारे दिन में तो चैटिंग करेगा सिंपल रहेगा उसका मोबाइल।
सच में आप
वो इधर आ फोटो नहीं ले सकता था इसकी वीडियो की
इनको पता नहीं था
हमको बोला ही नहीं क्यों नहीं बोला तुमने? मेरे को तो लेके जा रहा मुझे क्या पता मैं पीछे मैं सर कल मैं वो प्रदीप को जाना उसको सच
हेलो
पिंकी स्क्वायर में लग रही है क्या के पास में जो है इजीली टिकट अवेलेबल है
और उनका तो पेटीएम पे ऑफर भी चला 50% डिस्काउंट
है
300
हमारी करवा दो
सर 330 की टिकट थी
330 की
दवाई की टिकट है एक और उसमें मेरे को 165 की
ये तो बड़ी महंगी है ऐसा कुछ नहीं हमारा शौक है
करो
165 की
बुढ़ापे में भी लड़काना शौक है फर्स्ट देखूंगा फर्स्ट शो देखूंगा निकला ना पिक्चर का भागी जा रही
मेरे को तो 165 की पड़ी।
अरे बुज्जू जी ने नाही रे साउंड म्यूट करो रे
हेलो
पेटीएम से मैंने पे किया 155 का वापस आ गया
फ्री में होगी
तो 130 की टोटल निकल गया 50% डिस्काउंट कर दिया 165 मेरे पेटीएम में वापस
अरे 165 तो लगे ना
165 तो सर हॉल में बैठ के पिक्चर देखोगे तो
इंडियन बैकग्राउंड पर लेके और पल्सर में प्रैक्टिस चालू है
मतलब
सर मेरी एप्लीकेशन दे दो फिर
क्यों दे दूं
आपको
जो जमा हो गई वो जमा हो गई
आपने खुद बोला ना
ये ले खत्म हो गया अब तो सुन तेरा ये काम है तू चेक करके बताएगा मुझे मैंने तो मेल डाल दिया उसको कुछ एक्शन होगा तेरे को एक वेट मत कर देना ना कि निकलेगा समय तो मेल डाल दूंगा अगर नहीं आता तेरा तो मुझे बता और मुझे याद दिला देना फिर आपने मेल डाला था डेट आज मैंने मेल डाला मुझे याद दिला क्या ना प्रिंसिपल साहब को आपने मेल डाला
पर्सनली जाके
असाइनमेंट लगे तो मैं सब पे सारे पे असाइनमेंट
मैं समय पढ़ाते हैं पकड़ के आइटम बस
बोल रही थी एक पैनल बनेगी
तो बाकी सब लगे
सब ले
ऐसा करो अरे सर असाइनमेंट मेरे वाले से अलॉट कर दो ना इनको असाइनमेंट वही वाला जो और बच्चों को कर रखा है ना वही वाला इनको दे दो और एक कॉपी इनको दे दो एमआईएस वाला
एमआईएस का
अरे मेरे पैनल से जो और बच्चों को मैंने दे रखा है ना
तुम्हारे असाइनमेंट है ना
कैसे भरेंगे सर डाला तो है नहीं मैंने असाइनमेंट भाई और बच्चों को डाल रखा है इनको नहीं डाला है इनका पैनल बाद में बना ना
अरे मेरे दादाजी मेरे को बात तो सुन लो पहले
हाँ बताओ
हेलो क्या कि इनके जो नंबर है ना इनके जो नाम है ये पहले वाले पेयर में आ रहे हैं नाम
अच्छा
मैं सब नंबर अभी चेक कर लिए सारे बिठा के
तो इनको ये कह रहे हैं इनको दिख नहीं रहा असाइनमेंट मैंने तो डाल रखा है
असाइनमेंट का डेट चेंज कर लो
डेट चेंज कर दो डेट चेंज क्यों
आप करो ना यार कर दो यार
सर टाइम तो मेरा
सर आइए सर
भाग जा भी पहन दो कर ले जा ले
सर ये नहीं है दूसरा है
दे कहाँ है ढक्कन भी छोड़ देगा कल ढक्कन रखेगा तो मन में गिलानी रहेगी लिस्ट कहाँ है, कितने सेंटर्स से आपके जुड़े हुए जो हैं?
टोटल 13 थे, इनमें से एक हमारा नई वाला नहीं जुड़ पाया और एक ये स्टूडेंट वाला में 11 है, 11 सर, 11
audible to you or not?
Yes, sir. You are audible.
Okay, so thank you.
So good afternoon. I request all the local coordinators and participants to please be seated in their classrooms. So we are going to start the validation session. I request all the participants to come and be seated so that we can start the program. कितने हो गए? तो हम सर स्टार्ट कर लेते हैं बीच में. So good afternoon. So this is now the final and validation session, and we are fortunate and in fact honored that we have with us our honorable director, Dr. M.P. Punia. So who is basically the driving force for all these ICT based programs. It is because of all his efforts and inspiration from him that we have the institution started his ICT based program, and not only because of these ICT, we are now connecting all over our country, not only at national level, we are also connected at some places at international level also. So that give us a opportunity to expand our area of training. So today for this program we have 11 centers have been connected. So friends, throughout this program we discussed about optical advances in optical fiber communication. We started with the basic of optical communication system, and with the different sessions we moved from basic to development part, and then what is the latest development. Experts from Guru Nanak Dev University Amritsar, Guru Nanak Engineering College Ludhiana, from CSIR laboratory CSIO, they come to the studio and they shared their experiences with all the participants and the latest development in the field of communication. So this is the area now optical communication, or it is the era of photonics. So communication, all these ICT program I mentioned, it is only possible if we have a very, very strong background system. So that is only possible if we have to develop all the optical communication system, because it has near zero loss and infinite bandwidth. So I hope you all benefited from all these sessions, and now it is the time now for the participants to give their feedback and then interact with our director, how you are benefited. We have with us also Dr. Liswani, Dr. K.C. Liswani. He is assistant professor in mathematics, and he is also I welcome all Dr. Liswani and our director for this validation session. So now with this word, I hand over the dice to our director for interaction with different nodal centers. Sir, जोड़ो. Okay. बोलो. So gate Behrampur, Gandhi Academy of Technology and Engineering, Berhampur, Odisha.
Yeah, good afternoon, sir.
Yeah, good afternoon.
Sir, first of all, many, many thanks to Dr. and Professor B.C. Chaudhary sir for his coordination and cooperation for providing this very nice program. As we have been observing for all the 4-5 days with the fundamental things like from the fiber optics, fiber optic source, detector, and wireless communication, the space communication. Overall, it is covering all the communication field, like analog communication system, digital communication system, and satellite, optical, mobile computing. All the communication system is included overlay with this top technology, that is fiber optical communication system. And as it is highly essential for our digital India and the global communication system, as our central government is also very interested to form the digital India by providing the optical fiber communication each and every metro, towns, and overall the India. And it is very harmful, and fundamentally it requires for the technically students, staffs, providing the real knowledge about the communication system. And this program, this faculty development program, is very, very helpful for our faculties and our students. Those of the minimum doubts how to clear it has given such type of very good feedback to clear all the doubts with Dr. Professor B.C. Chaudhary sir, given very nicely the fundamental requirements and the implementation and the technology that is essential theoretically and practically. Also have given very good demonstration that has been impacted to our staff, and we also discussed Dr. Chaudhary sir's demonstration classes. It is very effective, because even if we have not such standard of laboratory, but what the basic things we have been implementing to our students, it is highly essential and very helpful, given as a feedback from your good office. And as we have been implementing this for global communication system and implementing all the fiber opticals, replacing it into the previous older one, since the fiber optics, the network that has been implemented for the last 1 decade or dozen of years, still then it is improving very good. A lot of technology that has been implemented in each and every communication field. And another thing I would like to say, sir, that is it provides our global communication system, a global village. The total world is included in a global village, and this is only the fiber optics that can be helpful to implement this type of status, this type of technology that is need from the grassroots level to a higher level of the research fields. And another thing I would like to say, there is a higher technology that has been also required. That is, I have heard from technical sources that our global, totally global system, this system is there, and another system that has been communicated to other planet. Like suppose many more planets are there, the distance of the one planet to other planet is some light years, thousands of light years. So this type of communication can be possible by the fiber optics only. And another thing, I have heard from a program that there is a communication is there, that is a planet to planet, and that planet, all the planet are trying to communicating with the other planet, and that is essential to receive. The photonic system is essential to convert the coding system, and that can be possible through the fiber optics. Such very nice program we have been patched, we have been communicated with you, and we have enjoyed very lot. So lastly, I would like to thank Dr. B.C. Chaudhary sir, Dr. Punia sir, and Swami sir, those have on with us. So lastly, I give many, many thanks for this program, and I would like to say, so such type of program should be provided by you forever, and we are also interested for the further programs. Thank you, sir.
Thank you.
Thank you very much for Professor for input. You are teaching this fiber optics in which year? You are engineering teacher or from physics?
No, sir. I am an engineering teacher. I have been communicating with the students, all the SCT, DCT, and that mobile computing, also satellite communication for the computer faculty branches. So as this program also provide me very good fundamental knowledge about all the communication system, so I am very interested for this program, sir.
Suppose this same program you would have conducted in time to come. Suppose opportunity is given to you, that same program you please plan, please conduct.
Okay, sir. Thank you, sir.
No, just you please listen to me. Professor Chaudhary Sahab has made some 5 days program, some sequence of the lectures he has done, some experimental work also he has done. What changes you would like to have so that the program may become more effective?
So this program is, it is really the different faculties, they have given the different branch and different knowledge as per their experience and knowledge. If this may be implemented, some more faculties, those of the experience upon the basic different fields, then it will be more effective than this program, sir. Because
which faculty do you included? Electronics?
We have included electronics, physics, instrumentation and control.
Okay, so three specialization you included. They are saying some more teachers can be, even computer engineering teachers can also be benefited. So we can include them also. Polytechnic
and electrical
teachers,
also.
Electrical also. So certainly in time to come, those branches also will include. And this excellent setup which has been shown to you, splicing also,
OTDR.
You people are having these facilities at your institutes or not?
We have all facilities, but overall the minimum that our BPOD syllabus that's covering in our laboratories, we have been implementing that.
Yes. So sometimes you please do plan to come to Chandigarh. You see our laboratories, and even some rigorous training for your technical person also can be imparted by NITR Chandigarh. Will be very happy.
So we are interested to visit your laboratory and then to idea about how to implement the higher status of technologies in our institution.
Yes. If we want whatever we are having, it has to be utilized up to the maximum possible extent. The huge money we have spent on this one, and Dr. B.C. Chaudhary Sahab is having a lot of practical expertise with him, then the laboratory facilities which we are having. Whatever we are having, it has to be shared with whole nation.
Sir.
Whatever money we people are spending, it is for whole country. Everyone, even students. Please do plan come to Chandigarh with your students also. Some program Chaudhary Sahab is conducting for students. They are staying here for 6 months even. 6 months program on nanometal. He is having specialization in nanometals also. So one laboratory they are having on nanometals, another one is this fiber optics. So in both the areas we are quite competent, and you please come with students also. This type of exchange we need. We want the exposure of this NITR Chandigarh to everyone. This institute should not be a regional institute, should not be a national institute. It should be connected everywhere in the world. And whatever has been transacted during these 5 days, every lecture will be available on NITR Chandigarh Technology Enabled Learning web portal. Please give that link also from where teachers can get these lectures. Even please popularize our links to students also. Just like NPTEL, no, whatever has been transacted here on NCTL, and just you'll have to put NCTL. Even if you are having mobile, in the Play Store, in Google Store, just you'll have to put NITTR. So our app, NITR Chandigarh app will be downloaded, and in that NITR Chandigarh app, all the videos, even our operation plan, everything is available on this app. Just I am showing you our app. This app will appear just when we are going on this Google Store, and through this smartphone, when we are having some Wi-Fi connectivity or if internet connectivity you are having in your mobile, all the videos which are available, which has been downloaded by us on this NCTL link, which we will be having on that NCTL link is there. Some options are coming on this menu, some options are coming, somewhere NCTL is also coming. Just you push that NCTL, and according to your requirements, electronics or physics or engineering education or mechanical engineering, whomsoever is interested in anything, it is there. Even the application which you people are sending for the purpose of registration into these programs, it is available in this app only. There is no need to have laptop to everyone. If you are having the smartphone and internet connectivity, you can connect us through, for your registration, you can connect through this mobile phone also. Our whole year's operation plan, around 300 programs in a year we are conducting. All those programs details are available in our operation plan, and it is available on your phone itself. So it's very good, and from Odisha, very good response we are receiving. Twice we have visited to Bhubaneswar also. We have discussed with your vice chancellor. Even I connected myself to your chief minister also, that how our expertise can be shared to Odisha students. So please popularize our plans and please suggest us that these are the requirements of the program. Even if it is needed, we are ready to come in your institutes also. Our experts can come in your institute and we can conduct there itself.
Okay, sir, we will try our level to
Yes, sir, you are most
communicate.
welcome.
And also, lastly, I give you many thanks for your supporting hand for future programs. So with this, I conclude. And lastly, I give to thanks to all. Thank you, sir.
Thank you. So other participants want to speak?
Yes, madam.
Okay.
Hello, sir.
So be brief because we have to cover all so many outer centers. Be brief to say your word.
Yes, sir. Hello, sir. Have a good afternoon to all of you, sir. And I am very much thankful to allowing us to have such a nice program. I came from Side-by College, Roland Institute of Technology. I am such motivated by your program that can I suggest our college authority to also having such nice and very good programs, sir.
Okay, very good, very good. And now in future, there is no need to come to this institute. Your institute will be connecting all the facilities, the minimum which is required. We are connecting you through Google Hangout. We are connecting you through social media. If you people are having a dongle connectivity, forget about 1 Mbps, 10 Mbps dedicated lease line. If you are having dongle connectivity, if you are having laptop, if you are having LCD projector, we will be connecting you from here itself in your institute. When you are asking questions from us, you use laptop mic. And your view which is coming to us, whatever we are seeing here, that is through this laptop camera. So no additional infrastructure at your end is needed. That's our contribution. That innovation we people have done. Initially, when we started these type of programs 2.5 years back, we were using this video conferencing. But video conferencing is a very costly affair. First of all, the video conferencing equipment you have to have, the cost of video conferencing equipment, and the requirement in video conferencing is at your end, you have to have at least 1 Mbps dedicated lease line. Then only this transmission is possible. So with the help of our students, we have given this problem to our MTech students. Can you identify, can you give the solution of this problem? Because in our country, the biggest challenge which we are having, the infrastructure. And infrastructure, this IT infrastructure. Even government of India is saying that everything should be e-based transaction, everything. The hurdle which we people are facing everywhere, our infrastructure, IT infrastructure is very weak. In many of the polytechnics, even we are unable to get a single laptop also. Forget about 1 Mbps connectivity. So whatever we are having with dongle, we are now able to connect. Earlier, our capacity was to train around 4,000, 5,000 teachers in a year. Last year, we have trained 20,000 teachers and around 5,000 students also we have connected. And surprisingly, the cost of training has gone down. Earlier, 5,000 teachers used to come here in NEET Chandigarh for the purpose of training. Someone is coming from Calcutta, someone is coming from Kerala. For 5 days program, at least he'll have to spend 10 days. No, 5 days travel is there, 5 days the training program. When they are traveling, we are paying them TA, DA, stay, everything. So those travel expenses are not there now. You are sitting in your institutes. Our training program starts at 10 o'clock. Before 10, you are conducting your classes. 5 o'clock, we are closing. 4:30, we are closing. After that, you are looking after your families. So productivity of the teachers have gone up and cost of the training has gone down, and benefit of this one is whatever has been transacted, it is available now online. Those videos which are available online, sometimes we are analyzing that are really people are using our videos or not, are people downloading those videos or not, are they going through our videos or not. You will surprise that our popularity is not only in India, even outside India. The downloads, when we are analyzing that who are the people who are going through our videos, when we are going through analytics, around 40% is outside India. We are very popular in US, even we are very popular in Pakistan also. And many phones, through Facebook, friends are connecting us. Sir, please add this topic, please add this area, please add this video. We are having the problem in this area. So presence of NEET due to this ICT, it is not only regional, it is not only national. We are having our presence at international level. Please take the benefit of this one. Whatever you need, that much promise I can do. Whatever you need, we may not be having expertise in that area. We'll invite experts anywhere from the country, even outside the country. If someone is available, we'll connect. So please take benefit of this one. Thank you.
Okay. Last, I will give special thanks to Dr. Chaudhary for his very clarity to every bit of points. So I am very much thankful to sir.
Very good, very good. Thank you, ma'am.
So one of our participant belongs to that engineering college. Bignan, you want to touch something?
Please.
All the others. Okay, very good. Very good.
Hello.
Yeah.
Sir, I would like to thanks to Chaudhary sir. Sir, actually you explained all these things about the optical communications with the advanced optical communications. And right now in last August month, I have completed my MTech, and I have completed my project in four-way mixing nonlinear effect. That's why I am asking lots of questions, and till now I am working over that FWM only. So in that field, whatever the doubts are there, I have already cleared. And I would like to thanks last madam was came Baljit madam. She's also clarify all the doubts. I would like to implement all the sessions what they discussed with Baljit madam. Actually, I would like to implement that systems in my project so that I can improve my project also. And I would like to thanks again the director sirs. And this is my first time FDP program I have attended over here. And this is such a nice thing that I can't imagine also. So another thing I would like to implement over here, if another sessions will come that regarding opti systems, if another sessions will come regarding opti systems, if one can explain all these things, then it is very much helpful to us.
Yeah. Okay. Okay. Definitely, we will include it in our future programs, and still, of course, you have cleared many of your doubt. In case you have any other queries, you can interact with me through email, or maybe you can talk on the phone. Our help will always be available to you in this area.
Okay, sir. Sir, one more thing. In sometimes during the program, sometimes the audio was not clearly audible. So I would like to say some things over here. The technical problem of audio that should be clear more and more.
आप बताओ, अर्जुन बताओ what they should have at their end for having good audio, having good video, and good PPT which is being transmitted from here. Please speak from there. They'll be able to listen.
Yes.
Yes,
Sir,
please बताओ.
Basically, sir, at your end, you require one laptop with properly working internal webcam, mic, and.
Sir, actually, we are doing all these things. The thing is that even if the audio is not coming, but downloading all these videos, I am getting all these knowledges, because it's very much important to learn all these things. So immediately after going to evening in my home, I have downloaded all these things. So that is not a matter. But if a live program will coming, so we can ask all these things, doubts, all these things.
Well, you see, during the live program, sometimes at receivers and you will get lesser uploading speed. That's why the audio will get a little bit disturbed. So after the at the YouTube, you can download this session with proper audio. And
just please listen, Arjot. My suggestion is, one part is your connectivity. No, if connectivity is poor, then we can't do anything. If connectivity is there and still the quality of transmission is poor, what they let to have? First of all, this speaker, the mic. If external, if you are putting, what are the specification of that one? What type of speakers they let to have, so that the quality of this transmission may become good?
Sir, it is not because of the hardware problem. It's because of the
only internet.
Yes, yes.
Only internet.
Yes,
but many a times you are saying, no sir, उनका जो है वो system ठीक नहीं है, उनका वो जो है mic ठीक नहीं है.
Sir, इनको जो connect किया था, इनके पास properly.
इनके पास तो है. We are connecting whole country. Can you provide some specifications that these are the minimum requirements one has to have, and we can send to everyone that you please keep these at least these instruments, these components, so that transmission quality after 3 years, I don't want to listen that quality of transmission is poor. One part is connectivity, forget, because it is not in our end. Additional features which are needed, please provide to them through mail to inform to everyone that this is minimum requirement everyone will have to have.
To revise the technical specifications.
Yes.
हम अभी भी वो पुरानी पटनायक साहब के टाइम वाली भेजते हैं वीडियो कनेक्टिविटी के लिए.
You yourself also said.
So we will take care in future so that we will revise our specifications also, so that you should be familiar with that. What is the minimum hardware, what are the specifications for type of equipment required to get better and better audio video connectivity.
Very good. ठीक है. Next go.
Sir, again I will say to my college, actually I am from Vignan Institute of Technology, which is nearer to Gandhi College. So I will say to in my college also they will conduct these programs in near future. And thank you again to Chaudhary sir. And definitely when I am having some doubts regarding all these topics like in optical communications, I will contact you.
Even I am inviting you also, any area where you are very confident.
Sir, one more thing.
Practically,
regarding the practical things, sir, I am also interested to go to your institutes to learn all these things, because practically video conference is not a good things to learn all these things, practical things.
Yes. So practicality is not possible. My request is, any area where you are very confident, you are very good, please do come here. We'll record you, and we are paying. If you are coming here for 1 hour recording is there. Chaudhary Sahab is paying 5,000 rupees. In any specific area where we are not having expertise and you people are having with you, please do come. So we want to have a very good team, very good network, strong bonding with all the institutes we want. Alone, no one can do miracles. For doing something very special, we'll have to have a team. है ना, हमें अच्छे लोगों की, अच्छे knowledgeable लोगों की टीम चाहिए. और again and again we are saying India is facing a challenge of good teachers. This won't serve the purpose. It will be serving purpose. Whomsoever is there, who is confident, his knowledge should be shared through this internet this benefit which we can take. भगवान रामचंद्र जी भी सीता जी को लाने गए थे. Alone he would have gone. चले जाते, वो ले आते, वो तो हाथ से इशारा करते, शायद सीता जी वहां पे जो है पहुंच जाते. But before that, he has made a very good team, जिसमें वानर सेना भी थी, हनुमान जी भी थे, इवन गिलहरी तक उसके पार्ट थे. And then when he could get succeeded, when he was coming back, he was appreciating to everyone कि यार हनुमान जी आप नहीं होते तो मेरा काम नहीं होता, जो है हम जीत नहीं पाते. So that type of appreciation, that type of bonding, that type of understanding, that exactly we need. So wherever you people are, even 10 minutes video if you can generate for us, please send to us. We'll be putting everywhere on YouTube, everywhere. This is the time now. This is high time now. Whatever we people are carrying, it should be shared. Even in NEET Chandigarh, I am saying no one should be retired from here. No one should be retired. Suppose I am here after 5 years, after 2 years, after 1 year, when I'll be leaving this institute, there won't be any footprint of mine in this institute. No remembrance will be there. What exactly I'm trying, I'm requesting to every professor, and they are doing whatever they are knowing, please digitize that one. And it should be in digital locker. It should be available for everyone. It should be on social platform. So we never be retiring, because whatever knowledge I was carrying, I have digitized here. So even if I'm not present, yes, that same purpose will be served by this one. So that type of initiative it has to be. And even developing contents, we people can impart training. आपको अपना छोटा वीडियो कैसे बनाना है, आपको ऑडियो कैसे बनाना है, क्वालिटी वीडियो कैसे बनाना है, which can be played during your classes, inside the classes, to the students, even through Moodle you can share with your students. So that type of training also we people can impart. Please.
Okay, sir. Thank you, sir. Again, many thanks to Director sir and Chaudhary sirs.
So thank you for very good feedback. So now we move to the next center.
Yes, sir.
Race Gyan Bihar University, Jaipur. Race Gyan Bihar University, Jaipur.
सर एक दो तो आप बुला दो यार, मेरे को नहीं पता.
मेरे को जब मैं किसी नहीं जानता मैं.
अरे दादा.
Dr. Bright Keswani is there at Race Gyan Bihar University, Jaipur.
आजो. अरे आ जाओ.
We will come to this place later on. JSS Academy of Technical Education, Neoda. Local Coordinator, Dr. Deepak Kumar.
Hello.
Hello.
Good afternoon, sir.
Good afternoon. Now our director is there. Now you can give the feedback about the program.
It's a very nice program. We have gone through all the lab demonstrations because we have conducted from on the behalf of Department of Physics. So we are lacking these experiments in our own lab, and we are very grateful to you for showing all these such setups so that we can start thinking about doing research in this particular area. And we are surely visiting your labs for getting more information on this particular area. And we have Professor Owen Pandey, who is the HOD of IC department, and he will like to say something.
Good afternoon, sir.
Good afternoon.
I am head of instrumentation control engineering department here, and this course has been run in at an appropriate time because in the our semester is starting from January, and we have this this is required in our syllabus, and our faculty has benefited very well. And particularly as it has been told that laboratory demonstration has been really good. So I congratulate Dr. S.C. Chaudhary, who has been behind everything. Sir, Director Sir, I would like to ask overall question on this STC. We were getting some reimbursement for biscuits and tea for our private institutions also. And it has been very embarrassing for us that we are unable to offer. Would you kindly consider it? And particularly, we do not know what happened, how, why we are being discriminated when government institutions are there. Our same participants, if they are there, they will be offered, and not for us.
And I can understand your grievance, sir. And for this one, I am feeling sorry also. Actually, up to last year, we were not having any discrimination between private and government institutes. But actually, I said as number of teachers to whom we are imparting training, it is continuously increasing. The cost which was being associated with this one, because from every institute which was we were receiving, it is around 2 lakhs, 2.5 lakhs, and in a year, thousands of institutes we are connecting. So it was very difficult us to pay that much amount. So some restriction we have put, only 4,000 rupees we are paying to your institute. शायद चाय बिस्कुट अच्छे से आ सकते हैं उसमें 5 दिन के लिए. चाय बिस्किट तो 4,000 में हो जाएगा, सब अरेंजमेंट कहो तो 4 का 8 कर दूंगा मैं आने वाले टाइम में. बट दैट होल if your teachers are coming here in ICT program, your teacher are coming, every TA, DA, even stay, food, I think we people are giving. But if you are in your institute, only that restriction is there. यही है तो साहब इसके अंदर जो है. चलो हम देखेंगे अगर इसकी वजह से कोई नुकसान हो रहा है चाय की वजह से या मोटिवेशन कम हो रहा है टीचर्स का, certainly will take care.
Sir, this 4,000 which you are paying, 2,500 is for the coordinator, and 1,500 is for the technical assistant for working it in ICT mode.
Achha,
so there is nothing.
We will find out which we can provide. If we can provide and during the sessions.
We are doing same thing. What all that 4,000 we are spending on our participants, but those who are coordinating, if possible, they can also.
Sir, we'll find out solution. We'll find out solution.
But working tea and snacks, they will see
some mechanism will be provided. Okay, sir. Okay.
Thank you, sir. Thank you.
Sure. We'll
may I?
Globally stood up.
May I want feedback from any of the participants regarding the limitation of the program or some topic you want to add in this program so that we can improve our contents? Feedback from any participants.
Hello. Hello, sir. I'm from JSS 80. I am one of the participants here.
Okay, ma'am. You continue.
Your program was very well designed. All the OFC design technology, all the aspects like simulation and verification, it was very elaborative. Especially the lab sessions were very elaborative and interactive. And I would like to say special thanks and congratulate Dr. Professor B.C. Chaudhary. His lecture delivery was very, very nice. He was very detailed and very communicative. Thank you, sir.
Thank you. Thank you very much. Now we go to the next center. Global Institute, Amritsar. Global Institute, Amritsar.
Hello sir, I am audible.
सर आप सिस्टम के बारे में माइक मत यूज कीजिए.
ये भी चेंज करिए.
हेलो यस सर आप सिस्टम के पास आके कर लीजिए.
Hello. So please be near to your laptop. Come near to your laptop instead of using mic. Now you are audible. Please continue.
Sir, your program is very good, very nice. It includes lab demonstrations, and lab demonstration is very necessary for this program. See, in every engineering applications, if we not run the lab demonstration, it is not complete. And one thing I want to add to this program that live demonstration of some industry people like Reliance is there, Vodafone is there, Airtel is there. They are all working on the optical transmission system, and we should say some include industry people to give some demonstration on live basis. There are daily basis cuts on the optical fiber are there. You also tell us splicing is very good, and also give the demonstration of the internet is very nice. It is also based on the online demonstration of international level. But I want some more live demonstration of industry, like include some session, one or more session of industry to give a demonstration what real-time problem they are faced and how these problems can be solved. And rest of all the contents is very, very nice, research oriented. It includes very recent trends in optical fiber communication. Also, more research oriented courses. But students in our living classes, they are not
To mic.
जो अलग हमारा कम्युनिकेशन में लाइव चीजें
तो अपने प्रोग्राम शुरू करते हो ना उस टाइम सब जगह इंस्ट्रक्शन एक पास किया करो.
May I request you to just use the mic of your laptop because you are not clearly audible at my place.
सर ये वाला माइक आप एक्सटर्नल मत यूज कीजिए.
Don't use the external mic. Use the internal mic of your laptop. Hello.
सर आप ये वाला माइक मत यूज कीजिए. जस्ट सिस्टम के पास आके इंटरेक्ट कर लीजिए. देन आप ऑडिबल होगे क्लियरली. सर आप सिस्टम के पास आ जाइए. ये माइक मत यूज कीजिए.
खोलो जी कड़े बंदे देखिए 16 नंबर लगा 16 नंबर.
सर जी आप ये वाला माइक. हेलो. हाँ जी सर आप ये वाला माइक मत यूज कीजिए. जस्ट सिस्टम के पास आके इंटरेक्ट कर लीजिए.
Hello, I am audible, sir.
Yeah, now you are audible. Please.
Yes, sir. So overall session is very nice, very good. Research-oriented session is there. Some section includes research-oriented optical splicing, bit-array demonstration, and practical. So I want some include industry level demonstration. Like communication industry are there, Reliance is there, Vodafone is there, Airtel is there. They're all working on the optical transmission. Their department is optical transmission. We'll include one session, trade all live problems. what are they facing, cuts are there, how splicing is done in a real time. As you demonstrate us the splicing by this configuration we can done. These equipments are very costly and it is very helpful for us to see that equipment, and it is very useful information for us. So we industry demonstration include in this session, and overall very good, research oriented for a faculty to pursuing a PhD or any MTech dissertations. It is very useful. For a BTech purpose, students are going to a companies and to demonstrate that problem. So we want to include some industry session for that purpose.
Definitely, we will be, in future we will try to have some interaction with person from industry, maybe from BSNL or from Reliance. But
yes.
because their systems are live system, so demonstration at their place may be difficult. But we will definitely arrange some expert from there so that he can share the technical problem what they are facing in the real time.
नहीं चौधरी साहब वो कह रहे हैं बीएसएनएल में ले जाके आप ट्रेनिंग करा रहे थे अपने जो ट्रेनिंग लेने आते थे स्टूडेंट्स, यू आर गोइंग देयर, ट्रेनिंग वाज बीइंग कंडक्टेड. Can you record their place when we are doing that thing? Can you recording will be done and then we can play here, no? है ना? अपने यहाँ पे कैमरा लेके जाएं, वहाँ पे जो एक्सपर्ट्स हों वो जो काम कर रहे हैं वो रिकॉर्डिंग कर लें एंड देन वी कैन प्ले हियर, नो?
जब भी कोई प्रॉब्लम करते हैं
बीएसएनएल से टाई अप है ही आपका,
वो हम रिकॉर्ड कर
वंडरफुल सजेशन, वेरी गुड सजेशन, विल ट्राई टू इंप्लीमेंट दैट वन. Amazing.
Thank you, sir. Thank you.
Very good. Okay.
So now we move to the another center, City Institute of Engineering, Jalandhar. City Institute of Engineering, Jalandhar.
Good afternoon, sir.
Good afternoon.
Am I audible to you?
Yeah. You continue, please. You are audible.
Okay. Thank you, sir. Sir, from the day I'm Rajesh from City Institutes.
Yeah.
Hello?
Yes, you continue, please.
Okay. From the day one, I watched your program, and it was really from the day one. It is from level 0, means the person who is not having any knowledge about optical fibers. That person also may know that what the technology it is and how does it work. And secondly, from the technical point of view, the persons who are in this field, they also know that how to troubleshoot and what the technical aspects of this program are. And the motivating part was the technical details, like how the ray optics work inside the Rayleigh criterion, then WDM and these technologies, how they work. Secondly, what the program which I like the most, the troubleshooting part, that what are the constraints while we design this optical fiber system. Because in designing, sometimes we don't know what are the constraints, and after knowing this, we can design the system very well, and we can cope up with the problem which may come further while designing the systems. Secondly, the other part was the simulation part, and that is very nice, and we would like to implement this simulation part in our college, so that the students may know that how to implement the system in the lab, so that if they get the opportunity in their fields, like in campus placement, and they have the time to work on the real-time systems, they know that how to implement these systems. So overall, these programs are very nice, and I'm especially thankful to your whole of the team on the behalf of my college and from my faculty members and the coordinator. And we thank a lot for this wonderful program, especially for Dr. Chaudhary. His domain knowledge is quite excellent. Means the way you explain concepts is very, very awesome. And the main thing is that the creation of interest. And my background is CSE. Okay. And I'm a little bit having interest in this networking, but in-depth knowledge of that means I know that it is a backbone of any network, but I was not knowing much detail. But now I have created my interest, and I watched all of the program, and all my faculty members enjoyed your program very much, and they are updated with their knowledge. Thank you very much.
So thank you. May I have any some feedback from one of the participants? How do you find? How you are benefited from this program?
Yes, sir. Ma'am is online.
Good afternoon, sir.
Good afternoon, ma'am.
First of all, I must thank on behalf of City Group of Institutes and all the participants because this is the OFC technology information was you have explained it in detail, and especially the laboratory demonstration we like it because in this way we will enhance our knowledge. So obviously this is very informative, and obviously our excellence is increased by attending this short-term program. And I must say a big thanks to Dr. VC Chaudhary and Dr. Bhatnagar and all the other faculty members who have presented their views, and it was very, very informative and a clear session. It is properly designed. So that's why I must say thanks to VC sir once again.
Thank you. Any topic which you want that must be added to this program in the schedule?
Yes, sir. Yes, sir. We want that the real-time implementation from any industry, so that when we work online, from the lab and from the simulation that we learn enough. But when we work in the industry, because when we have to work on real time, we need to know that how the actually things go on. So if you have that kind of videos or recordings at the real-time implementation of this optical fiber network, so that will be quite beneficial for those who are in this field and currently working, and those who are trying to switch into this area. Thank you very much.
So thank you. That will be taken care in future programs.
Thank you, sir.
So now we move to next center, Gyan Jyoti Institute, Banur. Gyan Jyoti Institute, Banur, Rajpura.
Good morning, sir.
Good afternoon.
Good afternoon, sir. So, Gyan Jyoti Group of Institutions. Sir, my special thanks to Dr. BC Chaudhary for this informative session. Thanks to Dr. Punia, the renowned speakers in the timetable we had, Engineer Randhir Bhatnagar, Dr. Umesh K. Tiwari, Dr. M.L. Singh, Dr. Baljit Kaur, and Engineer Navjot Kaur. Overall, sir, it was a good session on optical fiber communications. So fiber optics, as we all know, have become the industry standard for the terrestrial transmission of telecommunication information. Fiber optics will continue to be a major player in the delivery of broadband services. Carriers use optical fiber to carry POTS service across their nationwide networks. Today, more than 80% of the world's long distance transfer is carried over optical fiber cables. This is the latest trend in transmission. So basically, if we talk about the communication part, it is being dealt with by the optical fiber communication only. And it is the latest trend and the latest advancement in the technology part. BSNL is having in India, BSNL is having the utmost or the most advanced technology part in India. But the thing is, it is still lagging behind in distribution service. The private sector is leading in that front, although it is the private sector is using the technology given by the BSNL. So I think this is the part in India we are lagging behind. In the optical fiber communication, we have the latest technology with BSNL, but it is unable to perform accordingly or sustain. I thank NITRR for this informative session, and the certificates provided by the NITRR organization are very useful. We have already attended 12 NITRR ICTs. This is the 13th one, and they are AICT approved certificates. So basically, for the faculty development program, it is a very essential part. As in the interview concept, we can it is carrying a good weightage amount in the interview process. So I thank NITRR for this non-contact mode on ICT, through which we are able to get knowledge and practical based knowledge. As Dr. BC Chaudhary being a very renowned and experienced faculty in applied science department and in NITTR. He was himself performing the experiments. That was very encouraging for young faculty like us. So basically, we thank again NITTR for this, and so this is the feedback from us, and we hope for some more sessions like this in the future. That would really be helpful for our development, faculty development.
Okay, thank you. So now we go to other centers. Shreyas Gyan Bihar University, Jaipur. Shreyas Gyan Bihar University, Jaipur. Is Dr. Bright Keswani is there?
Yes, sir. Sir, it is a proud privilege for our university that we again attached and participated in OFC STP through ICT mode. We are very thankful to Professor Punia ji for our support and Professor BC Chaudhary ji. Sir, my faculty members learned a lot in terms of basics of OFC technology, that is overview of OFC, fiber configurations, transmission characteristics, optical resources and detectors, designs and analysis, etc. Sir, as practical part is very rare in nowadays, but the most beneficial part of this STP is the laboratory demonstration. Such as STPs are very relevant when government is favor of complete digitization of India. Thank you, sir. Our humble submission that kindly allow us, along with our students, to visit your laboratories for further learning under some collaborative process. And secondly, please send your PPTs and other study material and relevant videos for so that we can show them to our students also. Thank you, sir.
Okay, thank you. You are most welcome. You can send your student. You just float a letter to our director, and then we will plan. So your student can visit. We always allow the student, and all these PPTs they will be put on our website. You will find one folder under Applied Science Department. So in this folder, all these PPTs and video they will be put in within maybe next 2-3 days. So you will find all these PPTs on our website.
Can you send the channel also? The link of the channel. The videos will be available immediately. Even today's video evening are available on YouTube. That link you please send. Channel you please. You can download.
Thank you so much, sir.
Otherwise, YouTube and put there NITTR Chandigarh Advances in OFC Technology. You will find there also.
Yes.
Do you have any other suggestion regarding this program or from any participants?
Do you have any queries?
Feedback from any of the participants?
Do you have any query or your suggestions? No, sir.
Okay. Thank you very much.
Good.
Northern India Engineering College, Delhi. Northern India Engineering College, Delhi. Mr. Ankur Sood or Mr. Rajiv Sharma.
Yes, good afternoon.
Good afternoon. You continue, please, with your feedback.
Yeah. First of all, I must thank Professor Punia ji as well as your good self, Dr. Chaudhary, for conduction of such a wonderful program of optical fiber, where our faculty has been really benefited by this program. Our faculty already attended one earlier course also, and now this advanced course is really beneficial to them knowledge. But one of the suggestion is that you have talked about certain tools which are available. Tools for conduction of this OFC. Which program tools available? Softwares. Okay. So would you like?
Okay, I mentioned in the first morning session. I mentioned we have tool like OpSim, ModSys, or BPI, and even the OptiSystem. These are the simulation tools which are available where you can simulate and evaluate all these systems.
Are they available off the shelf or you have to buy them? Are they available off the shelf or we have to buy them?
Yeah, you have to buy them. These are licensed software and you have to buy them.
So I think an IEEE should provide that. I may request Professor Punia. So,
No, we have these software in our laboratory. If any of your teacher or participant want to use them, they are most welcome. They are open. We are open to all our technical institutions.
so that's right, but they should be available to us also.
No, they are licensed. They are network software. They are not available as such. They are not open tools.
Okay, they are not. Okay.
Yeah.
Goel Saab, first of all, thank you very much for sparing time and this initiative which you are having. I think among all the directors which I am observing, hundreds of institutes we are connected during last 2-3 years. In every inauguration program, sir, in every inauguration program and every valedictory you are present, that's a great motivation for whole of the institute. And I'm observing this initiative of yours since we were working all together in IIT Delhi for our PhD work, and same and even more than that you are carrying. It's great. It's a message for every teacher, the level of sincerity and enthusiasm and even queries also. I assure you, sir, I'll be requesting to Dr. B.C. Chaudhary, if those softwares are licensed software, then there is no chance. But if alternative of these one, just like MATLAB, one alternative is iLab. In the same fashion of these softwares, if some alternatives are there and which are available through open sources, we'll try to find out. At least sponsor some of the teachers so that the software which we people are having here, at least the training we can impart first, and we'll try to find the alternative of that one, solution of that one also.
It will be great help and it will motivate the teachers also. Yes. In the college, we have limited resources, as you know that.
We can understand. Yes.
Yeah, please, if this is being extended to faculty, then faculty can work much better than otherwise.
Chalo, we'll try, sir. We'll try.
Yeah, we will see. Otherwise, demo of these software are available on their website. You can practice on demo, and for actual work, you can come to this institute.
That can
be the possibility.
We can do that, but from NIT Chandigarh, if this help is being created, then this will take us to a higher level actually. What I would like to say is, because when there's no point struggling with the blunt tools,
No.
Once we have the tools, we can work on that.
Actually, Goel Saab, what we are doing, even with NIT Jaipur now, in MATLAB they are having around 100 licenses. We are having 37 licenses. So what we have done through cloud, we are sharing. Their license software we are able to use here. Our 37 they are able to use there. In the same fashion, this mechanism, because we are in the process of creating our own cloud. On that cloud, if you can put and it can be shared by our institute, then certainly it will be a wonderful innovation from our side. We'll try to find out the solution at the earliest possible, sir.
This will be great actually, because the same tools can be utilized and the teacher will start working on that.
Yes, true.
Because what happens is they keep on asking us that I would like to work on this when I cannot provide what they can do. But once we are having those tools with us, then we can force our teachers to work on that, and they will further motivated and will come with some good results.
True, sir. So thank you.
Thank you, sir. Thank you for your feedback.
Really, thank you, sir.
Now we go to Rajasthan Institute of Engineering and Technology, Jaipur, RIT Jaipur. RIT Jaipur.
Good afternoon, sir.
Good afternoon, ma'am. You please continue with your feedback.
Yes, sir. So this session we find it very educational one. It was filled with education, and we are very much aware. We got an education about OFC communication a lot, and we feel that it will be fruitful for the students to deliver about OFC education, sir. So we are very thankful to you to have such a session, and we hope for the more knowledgeable sessions in future also, sir.
Madam, in your institute, you are having one center of TSSC also, no? Telecom Sector Skill Council.
Yes, sir.
Hello. That center is working effectively. The TSSC center is working effectively.
Yes, sir.
How many students are taking training there?
How many students are participating? Sir, I will let you know that the data will be given by our ma'am,
Yes.
the concerned coordinator.
Yes. So what you can do?
Because I am from.
No problem through TSSC, because TSSC teachers, we are imparting training to them here also. So if some teachers are interested, TSSC teachers who are taking those NSQF classes, skill classes, we can impart training to them here. So please sponsor those teachers also. Okay.
Okay, definitely, sir. I will let you know the data.
Please.
Any other participant from RIT want to take some words or having any suggestion?
Yes, sir. Participant Green Maraya from he has done his MTech from NIT. He wants to say a few words on this conference, sir.
Hello, sir. Good evening, sir.
So tell us
Sir, good evening,
what
sir.
you got from this program.
Sir, it was very good, sir. We have learned lots of things from this program, sir. It was very well, sir.
चलो ठीक है.
Okay. Now, okay. So thank you for the feedback. Now let us go to another channel, Madhav University.
Connected.
नहीं connected है. Then RD Miri College, Ghaziabad. हो गया उनका. Now we have another institute, SRMS College of Engineering and Technology, Bareilly. So now thank you all the nodal coordinators and all the participants different nodal center. Now this valediction session, this is from our side. The connectivity, this is over from there. Now we will move to our classroom participants so that we can have interaction in the classroom area. So participants, in case you have any feedback or any suggestions, you are most welcome. You can give your suggestion to our director so that it will be extended to our department also.
Any suggestion? Yes, please. नहीं आपकी फोटो कैसे आएगी फिर वहाँ लोग सुनेंगे कैसे आपको ना everyone is listening to you every center is connected us no so they'll be listening whatever you'll be suggesting they'll listen.
Good afternoon to everyone. Firstly, I want to say thanks to Dr. B.C. Chaudhary for providing us such a comfortable atmosphere and for providing us such a very good knowledge about each and every aspects of the OFC. Very minute topic is covered in the session. And I would like to thank the director of this college, Dr. Punia sir, for this comfortable zone and for imparting the knowledge regarding not to their own campus students, but for everyone to share the knowledge. That is the main concern. I feel very innovative that director sir is taking very keen interest to share their knowledge and share their resources with another colleges. That is the one which I feel very intellectual ones regarding the director purpose. Mostly the directors need not to want to show such keen interest about this, that our resources have to be shared by other colleges. That is the one I feel very appreciated about you, and your resources we must want to use for our students also.
Sure, thank
We must visit with our students to
Thank
your
you.
college. Thank you, sir.
Any other participant?
Very good afternoon, sir. It's a good opportunity for all of us. And my suggestion is that please follow most of the demo in laboratory, sir. Actually, laboratory portion is very interesting for us, and we learn more from the laboratory. So in next time, please, sir, take more demonstration in laboratory and so demonstration in theory, because we are very interesting results in laboratory, and we learn lot of things from the laboratory. And your software is also fantastic and very beautiful. Thanks a lot, sir.
Thank you. Dr. Swani, you want to say
Last
few
but
words?
yes. So all the participants and coordinators at different nodal centers as well as the offline participants. So on behalf of Applied Science, I want to convey that we have already started the program on applied mathematics, because mathematics is a tool for all the sciences, all the engineering. Without mathematics, engineers or science people will not work. So we have started in conducting short-term programs on emerging area of mathematics, which are very applicable. These are the applied mathematics in engineering, then operation research, advanced operation research, optimization techniques, then fuzzy logic in mathematical programming. So these courses are offline courses, and one ICT course has already been conducted on advanced operation research, and we are also in process of developing applied mathematics lab. So I want to convey that the participants who are willing to know the knowledge about the applied mathematics and laboratory areas where we use and apply the softwares, mathematical softwares. So this is what I want to share with you. So this is.
So some last concluding word from
Yes. So Professor Chaudhary Sahab, participants who are sitting here, the participants who are connected, directors. First of all, I'll extend sincere thanks for all the centers, in fact, to be connected with us during last 5 days. And special wishes and special thanks to Professor Chaudhary, who could at least create interest. And that's the foremost task. When we are saying quality education, in quality education, first starting point is creating interest of the people who are listening you, people who are connected to you. Suppose you are taking class of 60 students, foremost task of a teacher is, first of all, suppose I am teaching applied physics. My task is to create interest of those 60 students in that of my subject. If I am teaching 260 students, and if in an hour class, the target, it has to be, I am speaking only 20 minutes, students are speaking 40 minutes. If that type of environment you can create, that's in fact real teaching. So creating interest of the students in your topics, in your areas, and then imparting training to according to their requirements, according to their wishes, according to their queries. So creating interest, imparting training according to their wishes, and finally when they are going out, they should be able to deliver. That's the quality education. So the interest which you have created, everyone is appreciating, and particularly your practical part, they are appreciating. My suggestion is, sir, next time, one of the professor, it was a very important lines of him. He was from computer engineering, and he said, I was not knowing ABCD of this program. I was not knowing about ABCD of OFC, and now I'm very good. So start from ABCD, start from scratch. Don't assume that teachers are knowing many things. Yes, scratch से, basic से शुरू किया. Now my very good, very good. अब मैं ये चाहता हूँ कि बेसिक से भी नीचे जाओ आप, और go below the basics. Yeah, school level. We have to start from there, because in this country we need technical hands who can work with their hands, and that will start only if you are going below the basics. Forget about fundamentals, you go below that one, and many suggestions are coming that practically where it is being done. Because in OFC many faults are there, and in country we don't have people who can join them, who can make at least that joint. कहीं पे भी नहीं है, कहीं पे भी नहीं है, कहीं पे भी नहीं है, कहीं पे भी नहीं है. Even condition of the laboratories are, sometimes back we were interviewing some of the electronics graduates. We wanted 1 or 2 technical hands here who can impart training, hands-on part training who can impart. We have interviewed around 24 students. All they were having BTech degrees in electronics, and some of them were pursuing MTech also, MTech in electronics. First question I was asking from the students, have you seen oscilloscope? No, sir. Multimeter? No. Any electronic component, diode, transistor? No, sir. Practical नहीं पूछिए, theory पूछिए. Theory मेरे को चाहिए ही नहीं. Theory अगर जरूरत होगी तो मैं BSc के बच्चे को लूंगा ना, आपको क्यों लूंगा भाई? Why you are carrying engineering degree? Engineering means who should be able to do something by his hand. कुछ बना सके, कुछ product बना सके, कुछ design कर सके, कुछ implement कर सके. Those type of students we need. So serious concern of our products are, if you see our country, it's a huge nation. Huge nation. Population of ours is 1.2 billion. 120 crore लोग हैं अपन. And whole world is having 7 billion. Out of 7 billion, we people are 1.2. 7 divided by 1.2, if you do, every 6th person is an Indian on this globe. And if you combine China with us also, they are 1.35 billion. 1.35 plus 1.2 if you are doing, I think we are reaching to the figure of 7. है ना, 7 मिलियन जो आबादी है उसके पास पास ही अपन पहुंच जाते हैं. But the unfortunate part is, whatever we are having 1.2 billion, majority of them are human beings only. But if you want to develop, we want to have human resources. Human resources means who can contribute. We want the products which are coming out from our institutes. They should be able to compete at global level anywhere in the world, in any corner of the world. This country needs now dollars. We want money for the purpose of progress. We want good infrastructure. We want good colleges. We want good hospital facilities, the health facilities. And without money, nothing is possible. Every corner of the planet should be covered by Indian. But we are just theoretical people, no? Inside the class, in a week, 32 lectures we are taking in a week. In civil engineering, what we are teaching inside the class, everything is available outside the class, creating practical interest and all. And our products are not getting accepted also. ये कहा जा रहा है ना कि हमारे बच्चों को जॉब के योग्य नहीं है आपके बच्चे. And this is the situation.
Mostly private colleges में ये सब practical की फीस रखी होती है, वो खराब है, कोई नहीं चल रही होती. फर्स्ट ईयर अप्लाइड साइंस छोड़ दो, फिर उसके बाद सेकंड ईयर से उन्होंने
फर्स्ट ईयर में तो टीचर भी अच्छे पीएचडी किए हुए मिल जाते हैं, अच्छे एमएससी किए हुए मिल जाते हैं. फर्स्ट ईयर इट्स ओके.
ये होता है कि कोई प्रैक्टिकल्स होते ही नहीं.
अब ये आपकी इशू तब आ रहा है इन आवर कंट्री इन हायर एजुकेशन. व्हेन आई एम सेइंग हायर एजुकेशन, एजुकेशन आफ्टर 12th class. Up to 12th class we are having schooling, after 12th class we are having higher education. And we are having 800 universities in this country. We are having 43,000 colleges, just like colleges you are discussing. No, we are having 43,000 colleges in this country. And every year the number of engineering students who are graduating, polytechnic and engineering, if I am combining all together, this figure is around 38 lakhs. 38 लाख इंजीनियर आपके हर साल जो है बन के तैयार होके निकलते हैं. दैट इज मोर देन द पॉपुलेशन ऑफ सिंगापुर. सिंगापुर पूरा देश है ना, उससे ज्यादा तो आप लोग ग्रेजुएट बना के निकालते हैं यहाँ पे. बट acceptability of those engineers are very poor. They are not getting accepted, and our gross enrollment ratio is only 23%. Meaning of 23% is, suppose 100 students are passing 12th class examination, only 23 are entering into colleges. I am not discussing about technical education. Every type of education which is being imparted in colleges, only 23 are getting opportunity. 77 we don't know where they have gone. In US this ratio is 87%. 87% बच्चों को कॉलेज में पढ़ने का मौका मिलता है. We are having this ratio only 23, and we are having only 23, and still we are saying our products are not getting acceptable. तो जिस दिन अमेरिका जितना रेशियो हो जाएगा आपका 86%, तब क्या होगा इस क्वालिटी का? जब 23% को ही अपन जस्टिस नहीं कर पा रहे हैं, नहीं उनको बना पा रहे हैं, what we'll be doing with 87%? So certainly all responsibility goes on the teachers. In majority of the laboratory classes I am observing, teacher is sitting in a corner and students are working on the workbenches. If he'll be having confidence, he'll be always with his friends, just like BC Chaudhary sir.
Right.
Yes, when he's conducting experiment with his hand, it means he is having confidence. In laboratory classes, what we are doing, we are giving some 3 hours classes there. First, we are giving that one manual. It is 1.5 hours. It is taking for that writing that manual, and then some 10-15 minutes kits are there. Just we are giving power supply to that one. Some output is coming. Just they are noting down. Teacher is taking some quizzes, some viva. He is sitting in the corner taking some viva or quizzes. It means he doesn't have confidence. कोई quiz viva लेने की जरूरत नहीं है. किस चीज का quiz viva? आपको सब everything you are observing what student is doing. Everything, every marking, it has to be done there itself. What I was doing, I was professor at NIT Jaipur in mechanical engineering department. In NITs now, what is happening? The class size is around 120 students. Handling 120 students are very, very difficult. Very difficult. And normally in NITs, what has happened? They have been started some 50 years back. And that time group size, class size was of 25, 30, 40 students. Intake was 40. After that, OBC quota came and expansion of technical education came. From 40 to 80 it became. When they were having 40 students, the classroom size was for the 40 students only. When it became 80, what those smart people have done, NIT people, there are 2 rooms, 1 wall they have removed. It became 80 students classroom. So now 40 and 40, you see the length of the classroom. When it became 120, they have removed another wall. 3 कमरों को जोड़ दिया, and it became 120 class. Now you imagine You are standing here, your last student is 100 meters away from you. Very difficult to take theory classes. But advantage there is, the teacher who is taking theory classes, same teacher is taking practical classes also. In practical classes, 20 students are coming. So at least you can recognize them by face also, because they are staying with you for one semester. So what I was doing in that 3 hours class, laboratory class of 20 students, I said I won't take for 3 hours. I'll take only for 2 hours. No writing work, nothing is there. The formula, the equations, whatever is needed, whatever the outcome of that experiment it has to be, I used to explain. Now we all together will be combining, and this experiment will be conducting for 2 hours. Every observation table or calculation part or results part, whatever I need here itself. Please do here and please finish everything in 2 hours. And they used to finish. After finishing in 2 hours, we used to sit all together, 20 students, myself, in the laboratory itself we were sitting. And I was asking to every student that one by one, you please come on the board. Whatever you have learnt in 2 hours, you please explain here in 2 minutes, 3 minutes. What advantage of that one was, first of all, their agitation is being removed. When they are speaking in front of 20 students, that agitation is being removed. Second one, they were very serious during those 2 hours, because they were knowing that after 2 hours I'll have to explain. है ना, जैसे बीच में आप लोग बात कर रहे थे ना, बीच वाली लाइन में आप लोग बात कर रहे थे, वो बात अगर करेंगे तो आप पकड़े जाएंगे, उनको बोलना है. अभी जो ये प्रोग्राम चल रहा था ना, आप लोग बातें कर रहे थे, फिर मोबाइल लेके आप बाहर भी चले गए थे, बीच में अभी जो आप बैठे हैं टीचर, आप बाहर भी चले गए थे, तो इस तरह से वो जाएंगे तो पकड़े जाएंगे ना वहां पे. यहाँ तो आपको एक्सप्लेन करना नहीं था, आपको तो सर्टिफिकेट मिल जाएगा जो सब देते, पर हम देते नहीं थे इस तरह सर्टिफिकेट. वी सेड नो, यू हैव टू एक्सप्लेन हियर, यू हैव टू एक्सप्लेन. Okay, so like this one we were spending 3 hours. Then I used to say to students, now you go in your hostels or wherever you go, whatever you have learned today, you write it in 6 pages in the form of a research paper, just like title of that experiment, abstract of that one, introduction part, literature review part, the experimental setup, plan of experiment, observation table, calculation, results and discussion, and then references also related to this experiment, whatever is available on Google. Go on Google, research papers, books, journals, everything you try to get from there, and you write down that in the form of a write-up. And these days, the problem which we people are facing, even the writing skills of the students, that is becoming very, very poor. When we are saying communication skill, meaning of communication skill doesn't means only English, doesn't means only speaking. Communication skill is you are speaking, you are listening, you are reading, you are writing. All 4, if you are combining all together, it is becoming communication skills. That writing skills are also becoming poor, because due to this SMS, due to WhatsApp, we are in place of you, they are writing you, and that type of skills they are having with them. So I said you write in 6 pages, and through mail you please send to me. And they used to write also. So in a semester, you are having 120 students, 6 groups used to come in different times for conducting experiments. In a semester, they are conducting 10 experiments. 120 students, how many mails I'll be receiving? 120 students and 10 experiments in a semester they are doing, how many mails? 1200 mails I used to receive. 1200 mails, and the attachment was in the form of a Word format, and that is the write-up which they used to send. Every write-up I used to check, and in Word there is a command in the name of comment. You can write your comments in different colors there, that this is the shortcoming, this is the, you improve this one, and like this one I used to send back mail to every student. The benefit of this one was, after doing 3-4 experiments, some of the students have started to suggest me, sir, that experiment in place of doing this way, if this would have been done like this one, it would have been much better, because that journal is saying this one, that book is saying this one. So it was the happiest situation. It is a happiest situation for a teacher if students are suggesting, sir, this improvement is needed, और अपन जो कर रहे हैं ये तो बड़ा लिमिटेड सा है, इसके तो बहुत स्कोप हो सकते हैं काम करने के लिए, because now they are having burning curiosity in their mind. You have created interest of those students in the same fashion. तो जैसे अब आपका जो 5 दिन की बात कर रहा हूं, मैं आपके 5 दिन वाली करीब जो है 150 दिन की बात कर रहा हूं. So at least we could create interest in their minds. After doing 7-8 experiments, some of the students have started to present those small write-ups, into some small seminars also, in small conferences also, workshop. That was a conventional experiment, conventional experimental setup. कुछ नया तो है ही नहीं उसके अंदर, उसमें भी कुछ नए आइडियाज उन्होंने डालने शुरू कर दिए, जिसकी वजह से उनके पेपर एक्सेप्ट होने शुरू हो गए. Now, because you have created interest in that particular subject and they have gone into the depth, the practical part as well as theory part also, when for the purpose of recruitment, industries were coming. Industries, when they are coming, first question they are asking, what is the subject of your interest? आपके इंटरेस्ट का सब्जेक्ट बताओ. अब वो सब ने ये बताना शुरू किया, सर ये मेरे को जो आप इसमें से कुछ भी पूछिए. तो आपका एक पर्पज जो था, that purpose you could serve. But this thing checking 1200 mails, ये 10 to 5 वाले जॉब से आप नहीं कर सकते, है ना? If you are loving your profession, if you are meant for this profession, if you are concerned for your students, then you can do. अदरवाइज ये 7वें पे कमीशन का वेट करना या डीए का या टीए का, ये सारे के सारे करते रहोगे, never you will be able to do. Students are having lot of expectations from us. Students are having lot of faith on us. Even everything, even what we are wearing, what way we are moving in the class, how we are sitting in the class, what type of watch we are having, what type of mobile we are having, everything is being copied by our students. We like to become role model. और role model तब अपन बन पाएंगे जब everything will be keeping for the students. The student to whom you are teaching, if he is failing, if he is not accepted by the industry, it means you have been failed first. है ना? आपने अगर ग्रूम किया किसी को 4 साल के लिए, अगर वो फेल होता है, एक मेरे को किसी गुरु की बात, साधु की बात याद आती है. साधु ने कहा कि किसी भी आदमी को, किसी भी इंसान को मेरे पास 7 साल के लिए छोड़ दो, जो मैं संस्कार उसको दूंगा, वो संस्कार देने के बाद इवन भगवान भी, जो मेरी बताई हुई चीजें भगवान भी चेंज नहीं कर सकता. न तो कोई दुष्ट प्रवृत्ति का व्यक्ति उसको चेंज कर सकता, न भगवान चेंज कर सकता. दैट मच कॉन्फिडेंस पीपल और टीचर्स आर हैविंग ऑन अस. क्या वो अपन दे सकते हैं क्या? एनी कंट्री will be growing if teachers will be growing and teachers are having confidence and if teachers are connected, if teachers are concerned, then only things will grow. Otherwise ये भाषण देते हैं ना अपन 2020 में डेवलप्ड होंगे, 2030 में, never will be developed till our attitude will be changing and till will be feeling ourselves attached with these friends. और फेथ देखो आप लोगों पे, बच्चों का फेथ कितना होता है. छोटा बच्चा, मैं बताता हूँ, 4 साल का 5 साल का नर्सरी में जाता है ना, जब शुरू में छोटा सा बच्चा जाना शुरू होता है, वो कुछ लिखना शुरू करता है, ABCD लिखना शुरू सीखता है, क्या लिखना शुरू करता है, एंड आफ्टर दैट he or she starts writing some words also. Suppose he or she has written a word monkey and spelling of that one he has written MONKY. When we will be coming home, we will be assessing the answer sheets of our word, that children, and being parent guardian will be saying, beta, what you have done? Monkey spelling should be MONKY. Why you have written MONKY? The reply of that children will be, मेरी मैम ने ऐसा कहा. आप गलत हो, मेरी मैम ने. अपन उसको 18 घंटे घर पे रखते हैं, मैम के पास तो 6 घंटे गया, वो 5 घंटे ही खिलाते पिलाते हमें सब कुछ, अच्छे कपड़े, अच्छा सब कुछ करना जो है, एंड बड़ाई वो मैम की करता है, बिकॉज ही इज हैविंग मोर फेथ ऑन टीचर्स एज कंपेयर टू पेरेंट्स. अभी कुछ टाइम पहले वन ऑफ माई नेबर, he has gone out for 7 days. He was having dog. तो उन्होंने हमारे से रिक्वेस्ट की कि आप कुत्ता हमारा जो है आपके पास रख लीजिए, बिकॉज वी आर गोइंग आउट. Certainly we were the neighbor and we assume ourselves a very good neighbor. So हमने कहा कोई बात नहीं, कुत्ते का लालन पालन हम करेंगे, प्लीज कीप विद अस. Every hour we were getting the phone call उनकी मैडम से कि कुत्ते ने दूध पिया या नहीं पिया, उसने बिस्किट वो ठीक से खा लिए या नहीं खा लिए, थोड़ा सा ध्यान भी अच्छे से रखना उसको, रात को कपड़ा भी ठीक से उसको उड़ाना. Every hour we were getting the instructions for that dog. और आप जिन इंस्टीट्यूट्स में पढ़ाते हैं बच्चों को, 18 साल का बच्चा तो आता ही है अपने पास, है ना, और 4 साल के लिए आता है. नेवर वी आर गेटिंग फोन कॉल फ्रॉम पेरेंट्स कि बच्चे ने खाना खाया या नहीं खाया, बच्चे ने जो अच्छे से पढ़ा या नहीं पढ़ा. इसका मतलब उस नेबर की हमारे पे विश्वास नहीं था, लेकिन पेरेंट्स का आप लोगों पे विश्वास. अपने बच्चे को, कुत्ता तो छोड़ो अलग बात है, बच्चे को छोड़ के जाता है आपके पास, and never is inquiring कि बच्चा हमारा कैसा है. It means he is having lot of faith on us. कि अपने बच्चे के लिए भी वो अपने से कभी नहीं पूछता, उसको ये पता है कि our children are in safe hands, है ना? There won't be any problem with them because we have kept with our children with those teachers. So that reputation please try to maintain. और मेरा ये कहना है कि अगर आपकी इच्छा नहीं हो पढ़ाने की, पढ़ने पढ़ाने की इच्छा नहीं हो, मत पढ़ाओ. Don't go in the class. Go in the class only when you are prepared. When your face is shining, when you are energetic, when you are prepared, then only go in the class. Never teach wrong contents. आप कभी भी बच्चों को फिजिक्स गलत मत पढ़ा देना, कभी भी इलेक्ट्रॉनिक्स गलत मत पढ़ा देना. No eraser on this planet is available who can erase those contents which has been taught by the teachers and who has been inserted into the hearts of the students. कोई erase हो जाए, नहीं होंगे. जिस बच्चे को गलत सर्किट पढ़ा दिया आपने, and suppose he has become the circuit designer of an aircraft, he'll be designing that circuit. Aircraft is carrying 700 passengers. Sometimes he can spoil the life of 700 persons. तो आप तैयार नहीं हो, मत जाना स्टूडेंट्स के सामने. जब भी जाओ जब तैयार हो और आप डिलीवर कर रहे हो. After taking class, when you are coming out from the class, you are feeling very happy that today my class was very good. Yes, the way I delivered the content, the sequencing of the contents which I designed, the way I used the chalk, board, duster, everything, it was very good. If those type of thoughts are coming in your mind after taking class, you are a good teacher. You are a good teacher. Yes, बहुत अच्छा लगता हो कि आज मेरे को नींद भी अच्छी आएगी, खाना भी अच्छा खाऊंगा. In contrary to this, if you are feeling bad, यार आज मेरी क्लास अच्छी नहीं थी भाई, चला तो गया मैं, चली तो गई मैं, लेकिन ऐसे टाइम ही पास कर रहे थे. कभी उस कॉर्नर पे लिख रहे थे, कभी कुछ नए कोई सीक्वेंस थी, नए कोई कंटेंट थे. इवन द क्वेश्चंस व्हिच आर बीइंग रेज्ड बाय द स्टूडेंट्स, आई कुडंट रिप्लाई. इफ यू आर फीलिंग बैड आफ्टर टेकिंग क्लास, यार ये क्या कर दिया, मैंने तो ब्लंडर कर दिया, है ना, आज की तनख्वाह तो मेरे को नहीं लेनी चाहिए, जो है खराब इस तरह की चीजें आपके लग रही हो, you are having all the qualities of becoming a very good teacher because you are able to analyze yourself. You are able to analyze your shortcomings that yes, this could have been improved. But if you are in third category, जिसके कोई फर्क नहीं पड़ता हो, न अच्छा होने पे, न खराब होने पे, न कोई पुराने नोट्स आप लेके गए, बच्चों को समझ में आ रहे हैं नहीं आ रहे हैं, आपने तो जो वो लिखा हुआ है आपके कागजों में वो उस पे बोर्ड पे उतारना है. आपके अगर कोई फर्क नहीं पड़ता हो, no vibrations in your mind after taking class, better you leave this profession. Yes, you are not required here, but at least don't spoil, है ना, इसको spoil नहीं करो. So certainly you'll have to realize, you'll have to recognize that we are very powerful people on this earth. We are most powerful. Even किसी टाइम जब अपने यहाँ पे नालंदा और तक्षशिला यूनिवर्सिटी होती थी, ऐसा माना जाता है कि at the time of Takshila, around 4,000 years back, professors were directly connected to God. ये श्रुतियां और जो नाम होते हैं ना, श्रुति का सुना है, श्रुति है ना, जो वेदों में लिखा हुआ है ना, श्रुतियां जो है वो है जो भगवान से जो संवाद होता था और जो उनको याद होता था वो लिखते थे. दैट इज श्रुति. याददाश्त के बेसिस पे जो है लिखा जाता था, वो श्रुतियां थी. Means professors were directly connected to God. Even the king of any state, he was being governed by the teachers. Teacher के हिसाब से राजा को काम करना पड़ता था. No powers those kings were having. All the powers were lying in the hands of professors, teachers. That type of strength teachers were having. तो हमारा ये कहना है कि आप अपने कैरियर में you are molding around 3,000 boys and girls, 3,000 अपने कैरियर में, जिनको रास्ता दिखाते हो, आपकी वजह से जो इनको रास्ता दिखता है. Even it is being said, no, गुरु गोविंद दो खड़े काके लागू पाए, बलियारी गुरु आपने गोविंद दियो बताए. Your role is assumed to be even better role than the God. God is just creating. We people are molding, है ना, हम उनको मोल्ड करते हैं. कितना इंपॉर्टेंट रोल है. Even the student to whom you are teaching, and if he is becoming IAS officer, after becoming IAS, he will be touching your feet. वो पैर छुएगा आपके. Otherwise IAS को कह दो कि उस आदमी के जाके पैर छू दो, 5 करोड़ रुपए दे दो, he won't touch. You can imagine how precious you are, how costly you people are. So please maintain that decorum. In this institute, our target is whatever infrastructure, whatever work culture, ambience which we people are having. Our target is anyone who is entering into this institute, any teacher who is coming for the purpose of training, or any person who is entering into this institute, when he is leaving from here, he should have a dream in his mind that if my institute would have been like NITR Chandigarh, that dream would like to create. ट्रेनिंग का मतलब ये नहीं है कि यहाँ बैठा के आपको जो है हमने भाषण दे दिया, आपने समझी. एवरीथिंग, our guest house, our food, our work culture, our behavior, our dressing sense, everything should be of that nature कि हम आपके दिमाग में एक ड्रीम क्रिएट कर दें. And my humble request is, whatever shortcomings are there, even in food you stay, whatever shortcomings are there, before leaving, please convey to Chol Sahab that these were the shortcomings of NITR Chandigarh. But please don't say anything bad about our institute outside this gate कि NITR खराब था या Chol Sahab time पे नहीं आए. No. And there is no use of that one also. We'll improve only if you'll be communicating us. If outside this gate of the institute you'll be saying there is no use, तो कहिए भी हमें ही कहिए. So at least that assurance we can give that whatever shortcomings you'll be pointing out, next time when you'll come here, वो shortcomings तो कम से कम नहीं मिलेगी. दूसरी कुछ हो, we don't know. So thank you very much. Best wishes, and I hope many programs of such type will be repeated. Thank you very much. And Rachwani ji, your mathematics program also same type of 10, 20, 50, 100 centers would like to get it connected. Whenever you do, your knowledge, your expertise has to spread everywhere.
Sure.
Teacher like you is rarely available.
Thank you.
No? Best wishes.
Thank you, sir. Thank you for your
Our team members also.
And